Yeah, it's that kind of night. We're ready to take flight, rolling like a rocket. Yeah, it's that kind of night. It's that kind of night. We're ready to take flight to another dimension, another dimension, another.
You may have more specific needs than what the out-of-the-box APIs can cover. And for those times, you'd want to bring your own custom ML models. Now, as mobile developers, we know how to advance rapidly. With MLKit, you can upload your TensorFlow Lite model and serve that through Google's global infrastructure. Your app can dynamically retrieve these models and evaluate them on device. This means you don't need to bundle the model with your app binary, and you can also update it without republishing your entire app. And since MLKit is available through Firebase, it's easy for you to take advantage of the broader Firebase platform. For example, experimenting with different ML models using A/B testing, or storing your image labels with Cloud Firestore, or measuring processing latency with performance monitoring, or understanding the impact on user engagement with Google Analytics. We are so excited about the possibilities that machine learning unlocks, whether you want to super.
It's a whole new world. It's a whole new. Can you feel it getting better all the time? Can you feel it getting better? Can you feel it getting better all the time? I'm seeing the light of day. I'm feeling real good. I'm seeing the light of day. I'm feeling real good.
You got that something that I like. Come over right now. I wanna say hi. I can't pass by, no, not tonight. Taking the room over. I gotta tell you, when we're spinning circles like nobody sees us, that's the moment that I know we have the most fun. Breaking the rules together, we can't be stopped. Yeah, that's how we do it. Taking a week away from it all. Let's stay up all night. It doesn't matter when we're spinning in circles like nobody sees us. That's the moment that I know we have the most fun. When we're spinning in circles like nobody sees us, that's the moment that I know we have the most fun.
The sun comes out and it's a new day. I'm gonna make it on my own. The sun comes out, I'm in a new way. I gotta pack my things, I'm going home. I'm coming home, yeah.
Let's build a house. We'll have a backyard. Something beautiful, something with a view. Let's build a house just for me and you. I'm coming home.
We can push to overdrive. We can take this past the line. Think of all that we can do with just one of me and one of you. Doing what we want now. No one's ever gonna take us down. Feeling like we're supposed to. chance to save somebody when they need you, when they need you. Going against the grain, don't be afraid. Yeah, all it takes is being brave. Walking up to the battle line. First watch lasting through the whole night. Call it an instinct, no time to rethink. Just acting in the moment. Smoke rolling out the windows. A selfless hero. Brave, keep being brave. One chance to save somebody when they need you, when they need you. Going against the grain, don't be afraid. Yeah, all it takes is being brave. Brave, keep being brave. One chance to save somebody when they need you, when they need you. Going against the grain, don't be afraid. Yeah, all it takes is being brave. Yeah, all it takes is being brave.
This was a big blow up this morning, but we ended up getting.
Welcome. Thank you for joining. Our session will begin soon. At this time, please find your seat. Our session will begin soon.
It's the good old days, tough times when nothing can go wrong. It's the good old days that take me back to the place where I belong. Step it up, got your work cut, you don't even care. Toughen up, you're a slacker, gotta cut your hair. But you don't care about the next generation. Don't care what your girlfriend says. We'll all dance to the new revelation. There's a shotgun. Everybody's talking about. Everybody's talking about.
Good afternoon, everyone, and welcome to the Web State of the Union. I'm Ben Galbraith, the product lead on the Chrome team, over in this session. So let's dive right in.
Let's go.
All right.
The web has special meaning for us at Google because our core mission to organize the world's information and make it universally accessible depends on an open ecosystem like the web. So it's incredibly important for us that the web is healthy and thriving.
And the web's evolved dramatically over the past few years, gaining significant new APIs and capabilities.
Probably the most important API introduced to the web in the last 10 years is the service worker. Since the beginning of the web, it's been about pages that user request and the browser renders. But the service worker changes that, introduces a brand new top-level abstraction that goes beyond what a page can do. Receiving events like push notifications, handle data synchronization, even after the page has gone away, letting you take control of networking so you can make robust offline web pages. Service worker have been in a good amount of browsers for a while, but now they're basically everywhere. With Apple rolling out support in Safari on iOS and macOS this March, and super hot off the press, Microsoft shipped service workers last week. Without now every single major modern browser supports the standard.
This is a huge moment for the web. We're really excited about it. So we've been using the term progressive web app to help explain all these new improvements, and the gradual rollout of Service Worker illustrates the importance of the progressive bit here, because PWAs that are written progressively to take advantage of browser features as they become available can seamlessly upgrade with no need to redeploy. So PWAs are now everywhere, and I want to share a few examples. Let's start with Ofo, a global bike-sharing company, which I hear's coming to the Bay Area soon.
Another one, is that right?
You can never have too many, Malta. And their brand new PWA uses your device's GPS to locate the nearest bike and your camera to scan the bike's QR code to unlock it, all directly in the browser. and that's it. You can start riding the bike. I love this example because it shows the power of the web's low-friction model. You skip all the steps of finding an app in the store and installing it. So Mother's Day is coming up next week.
Uh-oh.
I guess it makes 1-800-Flowers a timely mention. They're a global gift and flower delivery service, and after they shipped their new PWA, 50% more of their customers bought things on their site, which is pretty amazing.
Yeah.
Let's also take a look at Editora Globo, part of the largest media company in Brazil. After they upgraded their site, they saw a 50% increase in time that users are spending on their site.
Starbucks is another great example. They recently rolled out their PWA and saw the daily and monthly active users double. And because this site works well on desktops, users can order ahead from their desk. And somewhat to their surprise, Starbucks found that this is actually something users want.
So these are just a few examples, but it turns out across all sites that advertise with Google, we've seen that upgrading to a PWA delivers an average 20% boost to the website's conversion rate. That's 20% more people who wind up transacting on the site as a result. So this PWA movement that we've been talking about isn't just lip service. All of these new modern web capabilities deliver a materially better user experience, and it shows up in the bottom line of the businesses that we've all built on the web.
All right, Ben, since we are, at Google I/O, I thought it'd be kind of a good idea to talk about how Google itself is doing in the PWA space, right? I think that kind of makes sense. So let's start with our arguably most important web application, Google Search. Turns out the search result page is now backed by a service worker. It makes it both load faster and more reliably. All in all, reduces JavaScript download by users by a whopping 50%. And that in turn reduces interactions delayed by not having the JS around by 6%. At the scale of search, that's a huge win for user experience. The service worker enables a whole category of new features. If you don't have the service worker around, when you make a search and you're offline, you just get an error message, right? With a service worker, you get a friendly message that a push notification will notify you when you're back online and the search result is ready.
So let's go from our original service to one of our newest, Bulletin. They've got a PWA, and it's another great example of the low friction of the web, because their use case is all about helping people capture time-sensitive local news events right as they unfold, so you can get right into the site, into the action, without any install friction. And because the web is cross-platform, the Bulletin team has a super efficient development story, because they can get to desktop, Android, iOS, and more with a single progressive product and code base.
Another interesting case study comes from our Maps team. They built a version of their app designed for low-cost devices that are gaining traction in some of the web's fastest-growing markets, like India. The map is called Maps Go, and it's a progressive web app using Service Worker, Add to Home Screen, and other features. It's optimized for low network usage, so that it's better for regions that have unreliable networks, and even more important, it costs less money to use when your connection is metered.
Let's talk about media. It's a really important use case on the web. In fact, it represents 15% of all time spent in Chrome on Android, and 20% on Chrome for desktop, and over 30,000 years of video are watched daily in Chrome worldwide. I think that's actually just maybe my kids alone, I'm not sure, maybe. So a bunch of media-specific work has been happening on the platform. First, the platform's gained a bunch of new media features, like the Media Session API that gives you integration with lock screen controls on the device, and the media sharing site Vimeo is an example of a developer who just recently integrated this and sees strong usage, especially for longer media types. There's the Media Capabilities API that exposes rich stats about your device so you can make intelligent choices about which stream to use. There's picture-in-picture support, which we're showing here. This works across desktop and mobile devices. And there's the new Presentation API that allows you to explicitly control what you show on secondary displays. And let's talk about offline support for a minute. It's a major use case for many parts of the world, limited access to reliable high-bandwidth connections. And so the large Indian media property, Voot, as well as Globo, are enabling the new web offline media APIs into their sites. And there's a new next-generation, open, royalty-free codec coming. It's called AV1. We've developed it in partnership with over 30 major media and tech companies, and it provides 30% better compression over the earlier VP9 codec. So this is going to have a big impact, and it's shipping in Chrome later this year. OK, so we've been focused on mobile, but now I want to talk about desktop for a minute, because it's an audience that remains in the billions. And productivity web apps like G Suite continue to grow. And as we saw with Starbucks, even mobile-focused experiences are finding big traction when they come over to desktop. So we're starting to take mobile lessons over to the desktop platform, and one of the things we're doing is adding support for add to home screen to desktop Chrome, so that once you install a PWA on the desktop, it gets its own icon and its own top-level window. So finally, you can use Alt-Tab or Command-Tab, if you like, to get to those windows, which is something I've wanted for a long time. And because this window is powered by the full Chrome browser, you also get access to Chrome's browser affordances like autofill. So these new desktop PWA features are available in beta in Chrome OS today, and they'll ship to everyone in June, and will follow with Windows and Mac later this year. I'm also a big Spotify fan, so I'm excited about this next bit. They're shipping support for desktop PWA features, and you can experience it now on Chrome OS. I think it's a great fit because the web gives music fans a fast and convenient way to get right into Spotify and listen to their favorite songs, and their desktop PWA is a rich client that allows for playback of music and podcasts, and it has Google Cast and Spotify Connect support for remotely playing music, either through speakers or other devices or through Spotify apps that are running, and you can get right into it. And it's an app class experience with no installation hurdles or app updates to manage.
Well, that's Spotify PWA is cool, but let's talk about something even more exciting, email. You know, I'm a manager now. I spent like half my life in Gmail, and absolutely love the new upgrade and super awesome Gmail that we recently announced. Gmail was basically the original web app, and now it's an awesome desktop PWA with Service Worker-based offline mode. These new PWA features set up to be a true top-level window. Like Ben said, you can alt-tab to it and basically treat it like any other app running on your operating system. And so the boundaries between websites and apps are blurring on desktop as well.
So while we're talking about the desktop web, there's another example I want to share. AutoCAD. So AutoCAD popularized computer-aided design since its initial release in 1982, and it continues to innovate today. I think there's an estimated 2 to 5 million AutoCAD drawing files opened every day, and billions of them are stored in cloud-hosted file services. So using the web is a great fit to create a viewer for these types of files. They set out to create a web-based editor about 8 years ago, but they found that their complex, optimized code base was impractical to rewrite in JavaScript. So enter WebAssembly. It's a new web standard that enables high-performance execution of compiled code right in the browser, and it gives this code access to web APIs. So this opens up a bunch of interesting new use cases for the web, like enabling large C and C++ code bases, running performance-sensitive code right in the browser, such as a media codec, and it enables a whole new class of games on the web. In fact, Unreal and Unity, which are really popular gaming engines, can both target WebAssembly, and using WebGL, you can do high-performance 3D gaming. And the best part is that WebAssembly is available today across the major modern browsers in mobile and desktop. This is the first time in the history of the web that we've had a broadly available alternative to JavaScript cross-browser.
I think there's another really big moment for the web, actually.
So let's get back to AutoCAD. They launched a new web app in March that was able to take their 35-year-old code base that's literally older than the web itself.
It's also kind of older than me, almost.
I'm not sure which aged better, to be honest with you. But, and they were able to bring it to the web using WebAssembly, and AutoCAD is now universally accessible on all devices instantly. So if you're away from your workstation, you can make edits to your CAD drawings regardless of the device or operating system. And their engineering team now has a shared C++ code base, so as they make changes, they're easily integrated into that web app. So WebAssembly in Chrome is powered by V8, our JavaScript engine, so it's a good time to talk about JavaScript performance. We've continued our focus on optimizing for real-world websites. And in partnership with the community, we created a new benchmark called Speedometer 2. So this measures browser and JavaScript performance in a web app that's been re-implemented in over a dozen web frameworks. And we're pleased to share that over the past year, our performance on the score has dramatically improved, including a 112% improvement with React, with significant performance gains across other frameworks, as you can see.
Let me just try to rephrase that really quick. Your React apps will now run twice as fast compared to a year ago on the same hardware. I think that's really amazing.
So in addition to all this, V8 has implemented support for a bunch of powerful new modern JavaScript features, so be sure to check out the talk for more details.
As a web developer, I'm incredibly excited with the next topic. Who here has ever put together a web page with like Chrome DevTools and later found out it doesn't quite work the same way in other browsers? right? That sometimes happens. I think like 15 years ago, we developed for IE, and then it didn't work in Firefox. Browsers change, but the problem of subtle browsing capabilities never really has. But there is light at the end of the tunnel. In your own project, do you have like unit tests or integration tests? And if you don't, right, you probably kind of feel bad about it. The web has never had anything like that. So I'm incredibly excited that automated tests for web standards are finally a thing. These automated tests are shared amongst browsers to validate our implementations, ensuring that when new features like Service Worker come out, we minimize cross-browser capabilities and inconsistencies. And things are actually getting better. Browsers are working hard to becoming more compatible. And we want to especially thank the countless volunteers who are helping with web compatibility. As you can see in this chart, the number of web features on only one browser is going down over time. At the same number, the number of features on all major engines is constantly going up. There's a lot of work to do, but we're excited that things are going on the right track.
OK, so we're going to shift gears now and move on from talking about the web platform to the tools, libraries, and frameworks that we're working on here at Google to make web development more productive. Let's get started with the tool that we ship to every Chrome user worldwide, Chrome's own DevTools. Millions of developers use this every single day, and it keeps getting better and better. Please welcome Paul Irish, who's here to give us a taste of what's new this year.
All right. Thank you. Thanks, Ben. All right. So it's 2018, right? The world is asynchronous. And when we're debugging, we can't necessarily step through code line by line. Like, we have timers and promises and network activity to contend with. So the Chrome DevTools have transformed to adapt to this new asynchronous world as well. So let me show what it was like a year ago. We have this little function, set timeout with console log within it. And we'll just take a look at what happens. So this is Chrome from a year ago, and I want to step into the console, into the set timeout to pause in the console log. But when I hit step into, we step past it. This is not really what you want. But in today's Chrome, we have the same code. We step in, and we jump into the invocation in the set timeout. And again, now we're paused right on that log method point. So this is what we expect when we hit set timeout, right? Set timeout, like stepping, debugging, this should match our expectations of being in this asynchronous world. So I've showed this with set timeout, but you can expect the same kind of debugging upgrades when you work with web platform features like promises, post message, web workers, and more. So speaking of features, the web platform evolves quickly, right? Now, as it evolves, we as developers have to feel comfortable with the new APIs, the new objects, and how our code interacts. And the console has always been kind of our home base for that exploration. So I'm excited to share with you a brand new DevTools feature that I think revolutionizes how we interact with the console. We call it eager evaluation. And the best way to explain it is with a demo. So let's do that. Let's switch over to my machine right here. OK, so I got this little code right here. We have a regular expression. We're going to call exec on it. We have a string. Let me just finish off this string. Thanks. All right. Now, as I finish off everything, watch this. Now, I didn't hit enter yet, but I'm already getting the result of this evaluation. The cool thing is, we're going to update this as we type. So let me go over here. Will this even work if I change this to using like parens around the? No. OK, well, no. So the regular expression is a little brittle. I'll admit it. All right, OK. But I do see, OK, the 0 to 9 range. We could actually improve this. Actually, all three of them. Let's just select all three, and we'll just replace it with /d. And yeah, OK, looks like we're still pulling out the same stuff, so that's good. All right, and the other thing I wanted to do was I wanted to pull the area code out of this phone number right here. So while we have these multiple cursors, let's just go ahead and add some capture groups to the regular expression. All right, boom, 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 capture, capture, capture. So area code is 1. All right, sweet. So in a few short moments, we've explored an API, found a bug, made an improvement, and got the result that we were looking for. It's pretty awesome. All right, let's switch back to the slides. So really, that demo is just a taste. Eager evaluation enables you to work with all sorts of JavaScript language features, DOM APIs, your own JavaScript code. And the really powerful thing about it is that you can guarantee there will be no side effects. And the way that we enable this is that we introduce a new mode in V8 where we attempt to evaluate some JavaScript. And if we know that it's about to cause a side effect that will change the outside state, we just bail. So speaking of V8, we've been working hard to bring the same DevTools experience from the from the front end to the back end by making it a great tool for Node.js. So grab yourself a recent build of Node, and you can use the same feature set on the server that you do normally on the client. OK, so we have covered a lot of ground in this. If you'd like to see more, check out the DevTools talk, where we'll be diving deeper into all of this. Thank you guys very much.
Thank you, Paul. Thanks, Paul. So if you didn't notice on the slide, Paul's session starts bright and early tomorrow, but is really worth the effort to get an early start. Encourage you to attend. OK, I want to talk about another feature of DevTools called Lighthouse. This gives you clear guidance on how your website can be improved in categories such as performance, accessibility, capabilities, and more. And people are actually using this. So far this year, over 500,000 developers have used it to analyze over 2 million pages. So we're working hard to make Lighthouse better. And this year, we're launching a new version, 3.0, with a refined UI and higher quality insights. And we're announcing a new Lighthouse API to bring these insights into your workflow and to enable integration with other tools and platforms. Lighthouse generates some great insights, but in the real world, there are a host of variables that can influence how your site actually performs, like variable network conditions or the different devices that people are using. And so late last year, we launched the Chrome User Experience Report to help with this. It contains real-world performance data showing how Chrome users are experiencing over 4 million global domains. So you can analyze this data set yourself using the free BigQuery tool, or we've also integrated it into our PageSpeed Insights tool, which is the easiest way to use some of this data to see your performance. And you can also compare yourself to your competitors, which can be very motivating. OK, so we also introduced the Puppeteer open source project last year. This is a Node.js library for controlling the headless version of Chrome, giving you programmatic access to its rendering engine and to its dev tools. This project is on fire with over 3 million installs, and it's used by over 600 NPM projects. So, I mean, who knows? Maybe that syntax highlighter you just installed brought it along for the ride. You never know with these things. Most important of all, it has 30,000 GitHub stars.
That's actually the most important thing.
Is that why? I think it may be, actually. I don't know. So it went 1.0 in January, and it opens up a bunch of interesting use cases to integrate Chrome into your developer workflow. We're also releasing a new version of our Workbox library. This makes common service worker scenarios significantly easier. With it, you can transform code like this, which is about creating a cache for CSS files, into this.
I think Workbox is maybe the most underrated library from Google. If you're thinking about making a service worker, I'd really recommend to start with Workbox. It's incredibly easy instead of rolling your own.
OK, so if done poorly, sign up and sign in can be a big friction point for users. So our new one-tap sign up and auto sign in library, currently in early access, can drive really big impact.
Wait, is that actually the name?
Well, I mean, naming is one of the hardest problems in computer science, right? So, I mean, yeah, that is the name. But this library, it does create a truly one-tap sign-up experience. There's no typing, there's no identity provider to remember, and there's no password to create. And so when users return to your site, they can sign back in really easily. It works by drafting off of the existing sign-in that the user has on the device with a Google property, like Gmail, and it's based on the Credential Manager web standard. There are a few examples I want to share here of where the benefits come in. First, Redfin, a real estate company here in the US, saw an 80% increase in signups after implementing the one-tap library. And Trivago, one of the world's leading hotel search engines operating in 55 countries, saw a 2x increase in user sign-ins after using the library. So payments is another area where some optimization can go a long way. And we've just recently made Google Pay available on the web.
No, that's a good name.
Well, it took us a while to get there. But you can easily use this to accept payments from users who have cards saved to their Google account, and it works seamlessly across platforms and global regions, anywhere that you have users signed in to Google. And platforms like Shopify now let you integrate with Google Pay with a single click. All right, I want to talk about Web Components. We're a big fan of this. It's a set of APIs that let you build your own reusable, encapsulated components using primitives that are baked into the web platform itself. And it's only been in the past few months that Web Components now have native support in major browsers, and there are polyfills to reach all of them. So they give you a really interesting way to create nice, reusable chunks of code that you can pass around, and you can create them with just about every major framework. We created a website called Custom Elements Everywhere with up-to-date compatibility information on many of the modern frameworks. And Preact, Vue, and many others are now entirely compatible with the core tests. And our own Angular team just released Angular Elements, a first-class way to use web components within an existing Angular app. And speaking of web components, we created the Polymer project to help you build web components, whether to help your own team achieve reuse or to create custom elements for other developers. And this week, the Polymer team is releasing the next major version, 3.0, which adds support for ES modules and NPM, so it now works seamlessly with your favorite tools and frameworks. And the Polymer team is also unveiling a few cutting-edge new products here at I/O that are focused on creating fast-loading and tightly optimized web apps. One of these is lit-HTML. It's a small 3-kilobyte rendering library that uses the latest ES6 features that enables a web app to perform fast, efficient updates to the DOM, which gives you a really snappy user interface. And using this library, you can create really compact web components in terms of file size that work directly alongside your existing web components or other framework elements. It's a great example of leveraging the modern web platform to make your development easier and your apps more efficient.
Ben, I think it's fair to say that you just went through a lot of stuff, which actually kind of brings me to the next topic. Talking to developers, one message comes up over and over again, which is like, hey, Chrome team, you keep pushing out like all these awesome new features at I/O, talk about them, and like, but frankly, it's a bit overwhelming, and we're kind of lost on what to do. And obviously, this may not be many of you here, right? The web works great for experts among us who like to dive deep on topics. But not everyone is like that. Not every company can necessarily afford to always be up to date with the absolute latest capabilities and best practices. And if you start out with an expert team, your project might eventually be maintained by people with less context. It's important for performance to remain stable as your web app ages. I think we need to recognize for the web to be truly open and inclusive, we must bring these folks along as well and allow them to build great experiences. And I think that is where the project that I work on, AMP, comes in, and it fills an important niche. As a super short summary, AMP is a web component library and ecosystem for building reliably fast websites with great user experience. By encapsulating best practices and providing automated guidance towards success, AMP enables a vast range of publishers to deploy great user experience at incredible scale. Let's take a look at that scale really quick. Currently now there's over 6 billion AMP pages across 56 million domains, and most importantly, they continue to load in well under 1 second measured from Google search at the median. This translates into business success. Overstock.com saw a 36% increase in revenue on their AMP pages. Indian marketplace ShopClues saw a 29% increase in conversions, and Chinese news site Tencent News saw a 2x increase in time on site and a 40% decrease in bounce rate. Talking about AMP in e-commerce, maybe my favorite example is AliExpress. They went all in on AMP. They use it for their homepage, for the detailed pages, category pages on their own. And then they back it with a service worker to turn it into a progressive web app. And they have seen some great results. Now, AMP is sometimes seen as a technology specific to Google search. This is a metric that specifically filters out traffic from Google search, and they saw a 31% increase in conversion rate. And another important thing, they've been using it successfully in AdWords as well. So if you are making AMP pages, make sure to also tie them to your AdWords account. As I've mentioned earlier, we're really focusing on enabling a bigger set of publishers to create great experiences on the web. AMP Stories is such a project. Because content consumption on mobile is changing. Bite-sized full-screen storytelling formats are becoming more popular every day. But this development happens almost exclusively in native apps. The web is literally the best platform to build these, and it certainly has all the capabilities needed to create such content, but the technical investment that each single publisher would have to make to implement them is often prohibitive. And so they're drawn to these walled gardens that make things easy end to end. With AMP Stories, when publishers capture this emerging trend of storytelling, they'll be able to publish on their own website with minimal technical investment. And so we created M Stories, a set of web components for rich storytelling on the mobile web. They have great support for vertical video, animations, and tappable interactions. And while they're designed for mobile, they work great on desktop as well. Now, obviously, M Stories is a pretty radical shift. We're trying to progressively enhance the plain old web page. So we constantly work at implementing best-in-class features as easy-to-use web components that can be added to any document with minimal effort. This includes stuff like parallax scrolling, immersive light boxes, and things like videos that stay on the screen as you scroll. Well, our goal to summarize to get these behaviors added to as many web pages as possible to make sure that the web continues to make user expectations. All right, so I think this can be summarized as a lot of exciting stuff coming to AMP. But it did want to touch on a different angle. We realized that AMP isn't for everyone. Being opinionated naturally comes with limitations, which is not the right tool for the job. And also being opinionated means that some people have different opinions. Let's say your opinion is, I don't want to use AMP.
I don't know what you're talking about. I've never heard anyone say that.
Right? Sometimes happens. And if you think that's great, that's what the web is all about. And we're committed to make it happen. Let's take a look at the core features that AMP brought to the web experience. Reliable user experience, instant loading, and what we call seamless navigation. I think the first two kind of explain themselves. We talk about the last one, seamless navigation, later in this presentation. We want to enable platforms such as Google Search to provide the same innovative experience as they do for AMP today for all pages on the internet that implement a new set of web platform standards. So if you'd rather not use AMP, that's super cool. You still get access to the placement capabilities. Let's take a look at some of the factors that play into the standards-based version of the AMP experience. As I mentioned earlier, AMP pages load immediate and well under 1 second. With the Chrome User Experience Report, there's now a public data set that shows how fast a particular web page loads. So we're planning to use that data to find web pages that meet or exceed the benchmark set by AMP. But load time isn't everything. For example, a web page that loads super quickly but isn't actually interactive because JavaScript blocks the main thread does not provide a great user experience. So we're developing a new set of metrics that in combination reflect the more holistic spectrum of the experience the user has when they visit a page. Another feature that AMP brought to the web was privacy-preserving instant loading. We want to explain really quick what that means. To achieve instant loading, you need to download a resource before the user clicks, because otherwise the network will always be in the way and things won't quite be instant, especially on mobile. With link rel prefetch and link rel pre-render, the web actually had built-in methods for this. But it turns out that naive prefetching can sometimes not be what a user expects in terms of privacy. Because now the owner of a page's prefetch might be able to, for example, set a cookie and later send you ads based on that, although you never actually ended up going to the page. AMP's implementation of instant loading does not have this problem. And now we want to bring the same privacy-friendly features to the wider web. That is where an emerging web standard called web packaging comes in. Web packaging allows you to bundle up your web content, allow other parties to distribute it on behalf of you, while keeping the integrity guarantees of HTTPS. It has a bunch of awesome applications, like faster JavaScript loading, and we think it could actually form the missing primitive behind a more decentralized web. And then finally, it allows for the same privacy-preserving instant loading for all content on the web that provides web packages. It also has one very AMP-specific benefit, because those pesky google.com/AMP URLs that you don't like, I don't like, nobody likes, they're going away with web packaging. We couldn't be more excited. All right, I talked about how this web packaging standard is still very new, but we actually implemented it in Chrome. You can try it behind a flag today. My team has built an open source tool to create the packages. The Google Search team has built a prototype that works with these packages. And then finally, we worked with 2 companies, Food Network and Pinterest, to actually make web packages for their content. To give you an impression about how this all works together, please welcome on stage Ludo from Pinterest.
Thanks, Malcolm. At Pinterest, our focus is to help people around the world discover and do the things they love. We wanted to create a seamless experience on the mobile web that puts the right content in front of our users, enabling them to take full advantage of discovering content and browsing Pinterest without the friction of slowed load times or having to redirect to the app. This is why we're really excited to showcase how we're using AMP, PWA, and web packaging today in the product. So to do that, let's start with a simple search and switch to the demo. So I have a 5-year-old at home. She loves to make things, and so I'm looking for some Springcraft ideas for her. So here you see that when I click on the AMP page, it loads really fast, and even though we are on an AMP page, you'll notice that the URL says Pinterest.com. This is made possible by the web packaging technology that enables us to publish signed content that then can be served directly from the Google's cache. It also is a big win for the privacy of our users, as all of their actions are now contained within the Pinterest.com origin. So from here, I'll find a cool idea, and now you see that when I click on that, I was very seamlessly transitioned into the Pinterest PWA app. From here, I can take more rich actions, like save this to my board. Up. But more importantly, also, once I'm on our PWA app, then I can add Pinterest to the home screen, and from there, show all the cool ideas that I have collected for my daughter so that we can do them together. So at Pinterest, we're committed to making world-class experience for our users. We were the first platform at scale that enables AMP, and we've been able to shave over 70% of load times for our users, over billions of pages, and for millions of users. This is, in a nutshell, how our mobile web experience is evolving to help people around the world find inspiration. Thank you.
Thanks, Luder, for the awesome demo. To summarize, web packaging allows for privacy-preserving instant loading of web content. It does not depend on any particular technology like AMP to work. As I said earlier, the standard is still being finalized. It is not ready to ship. We do expect significant changes based on input from other browser vendors and the web community. But meanwhile, we're building out the infrastructure for all of you to be able to make web packages. Stay tuned for announcements later this year. Summarizing AMP. Publishers, merchants, and advertisers across the globe are seeing amazing success using AMP as the foundation of their PWAs and websites. If you already have AMP pages, check out the huge set of new web components to super easily enhance the user experience. We'd love you to use AMP if you'd like to benefit from Google's expertise and help to create great web apps. But through technologies like web packaging and advanced metrics, we're bringing AMP's core benefit like instant loading and reliable user experience to the wider web.
It's great to see what's happening with AMP. And throughout this talk, we've highlighted examples where the web connects users right to content without any installation steps. We see this low-friction model of web links as being akin to a superpower of the platform. As Malta mentioned, web packaging is a really exciting emerging standard for a bunch of reasons. And I'm really glad that AMP's able to use it to resolve URL issues, but I think there's a bigger opportunity here for web packaging to help the web lean into this superpower and to go from fast load times to no load times whatsoever, and to do it for the entire platform, not just AMP. So what would this kind of truly instant, friction-free experience actually look like? We'd like to show you a prototype.
Here's a demo that the Google Image team is exploring. So imagine you search for something, Google Image Search, and you click one of the results, right? And you go to the enlarged image, right? That makes sense. But how do you go to the web page where the image came from? Today you have to click that little button. You might do that. You might also not do that. What if instead you could simply scroll to the page instead? We think that with this experience, there would be a significant higher number of people actually move on to the next page, which would be amazing for publishers of web content and a great user experience as well. All right, this was, of course, just one example, but we're super excited to rethink how navigation on the web could work to truly make the web the most seamless and frictionless experience on mobile.
Okay, we are running out of time, so we should wrap up with the takeaways for the talk. The web presents a fantastic, compelling business opportunity for all of us. So use our insights tools, like Lighthouse, to understand where your site is falling short, where you have opportunity to get better, and upgrade your site using the latest web platform features.
Use AMP to easily create rich content and commerce experience and get consistently high-quality results.
And use our other libraries and frameworks like Workbox, Polymer, and Angular for more general use cases.
And now go make the future.
But speaking of the future, please join us this November at the Chrome Dev Summit in San Francisco, where we're going to gather as a community to talk more about the path forward for the web. You can sign up at this URL for more information, and we hope to see you there. Finally, thank you for attending the talk today. We hope you enjoyed it. Thank you.
Thanks.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits. We'll be making room for the
Hello and welcome to I/O Live. I'm Florina Montanescu, your host, and I'm here with Harris, the product manager on Android Auto. Hi Harris.
Hi Florina.
So tell me, what's new for developers for Android Auto?
So this is a very exciting year. We have all the new sets of the changes in the APIs for media and messaging developers, which is the biggest change that we made in a long while. For the media, what the developers can do is they're going to be able to do content browse forward, which is pretty exciting, and they're going to have a different set of layouts that they can use to actually present their content better to the user. For the messaging, we have new messaging styles, which is going to enable them to do, for example, group chat and a couple of different things. And for all the thousands of developers that we have for Android Auto, that's pretty exciting.
Am I able to already download the apps directly in the car?
Yeah, so actually what we have right now is we're also showcasing the preview of the Play Store Google Assistant in the vehicles. So we've announced today that we're going to be shipping some of these Google services with Volvo, so that's pretty exciting.
That's cool. Anything else that you want to tell us?
No, it's like I would say is like keep developing for Android Auto. If you're media messaging apps, we're excited to work with you.
Perfect, then check out the documentation that we have online and start developing Android apps. Thank you.
Thanks.
This is Florina for I/O Live.
Hello and welcome back to I/O Live. I'm Timothy Jordan and I'm standing here with Jorge. Jorge has been applying machine learning to diabetic retinopathy detection. Hi Jorge, thanks for joining us.
Hi, nice to be here.
Okay, let's start with what is diabetic retinopathy?
So diabetic retinopathy is the main cause of blindness among working age adults in the world. And the sad thing is that it's 90% preventable if patients would get regular eye exams and timely treatment. The problem is that people don't get regular eye exams, and so we've been going out and getting images of the retina in order to get a diagnosis to see who is at risk for vision impairment.
And how do you apply machine learning to the problem?
So right now, an ophthalmologist or an eye doctor, optometrist has to look at the image and determine what the level of retinal disease is before a patient can be referred, you know, if they need referral for treatment. So with AI, you can get an immediate grading of what's going on in the retina. So you don't have to wait sometimes an hour, 2 hours, or 2 or 3 days, or even weeks to get a response. You can act immediately for people that need care.
And I imagine this is a scalable thing as well for areas that don't have access to the same medical help.
Right. So vision impairment is expected to increase by 3 times by the year 2050. Wow. So there's just not enough manpower. There's not enough eye doctors in the world to be able to take care of everyone. So this is really the only chance to be able to get the people who need care into treatment, to be able to identify them and make sure that they're able to get treated.
I see. Yeah. What's next after this? What else do you think that you can apply machine learning to for people?
Yeah, so that's really exciting. It looks like AI can see a lot of things in the retina that humans can't. So we're looking to apply it to cardiovascular disease, neurological disease, and a host of other problems that we're hoping, you know, that the algorithm can find out with just a simple retinal image.
Awesome. Jorge, thanks for sharing your story, and thank you for the work that you're doing.
Thank you.
I'm Timothy Jordan, and this is I/O Live.
Hearing my parents playing guitar, that's probably my first memory. When I started learning about how sound waves are just vibrations in the air, my eyes opened to like a new world. And that's, I think, when it clicked that I knew I wanted to do engineering.
Daniel had a musical background. That's an important part of working on audio, is you have to have an understanding of the way sound works.
The scientists at MBARI wanted to figure out a way to, in any given day, count how many blue whales there were.
So the process involves recording audio from the ocean, but it's too much information for a human to try to look at and listen to.
We were able to turn those sounds to spectrograms, which are just images of what sound looks like, and fed those images into TensorFlow, this machine learning tool.
It allows us to take a mammoth pile of data and distill it into something meaningful.
It can answer a lot of questions about the way we are affecting the marine environment and how we can help conserve it. When I was a kid, I didn't think I was going to be a scientist or an engineer, but knowing that I'll never stop learning makes me feel pretty lucky.
Hello and welcome to I/O Live. I'm Florina Montanescu, your host, and I'm here with Harris, product manager on Android Auto. Hi Harris.
Hi Florina.
So tell me, what's new for developers for Android Auto?
So this is a very exciting year. We have all the new sets of the changes in the APIs for media and messaging developers, which is the biggest change that we made in a long while. For the media, what the developers can do is they're going to be able to do content browse forward, which is pretty exciting, and they're going to have a different sets of layouts that they can use to actually present their content better to the user. For the messaging, we have new messaging styles, which is going to enable them to do, for example, group chat and a couple of different things. And for all the thousands of developers that we have for Android Auto, that's pretty exciting.
Am I able to already download the apps directly in the car?
Yeah, so actually what we have right now is we're also showcasing the preview of the Play Store Google Assistant in the vehicles. So we've announced today that we're going to be shipping some of these Google services with Volvo, so that's pretty exciting.
That's cool. Anything else that you want to tell us?
No, it's like I would say is like keep developing for Android Auto. If you're media messaging apps, we're excited to work with you.
Perfect. Then check out the documentation that we have online and start developing Android apps. Thank you.
Thanks.
This is Florina for I/O Live.
Hello and welcome back to I/O Live. I'm Timothy Jordan and I'm standing here with Jorge. Jorge has been applying machine learning to diabetic retinopathy detection. Hi Jorge, thanks for joining us.
Hi, nice to be here.
Okay, let's start with what is diabetic retinopathy?
So diabetic retinopathy is the main cause of blindness among working age adults in the world. And the sad thing is that it's 90% preventable if patients would get regular eye exams and timely treatment. The problem is that people don't get regular eye exams, and so we've been going out and getting images of the retina in order to get a diagnosis to see who is at risk for vision impairment.
And how do you apply machine learning to the problem?
So right now, an ophthalmologist or an eye doctor, optometrist, has to look at the image and determine what the level of retinal disease is before a patient can be referred, if they need referral for treatment. So with AI, you can get an immediate grading of what's going on in the retina. So you don't have to wait sometimes an hour, 2 hours, or 2 or 3 days, or even weeks to get a response. You can act immediately for people that need care.
And I imagine this is a scalable thing as well for areas that don't have access to the same medical help.
Right. So vision impairment is expected to increase by 3 times by the year 2050. Wow. So there's just not enough manpower. There's not enough eye doctors in the world to be able to take care of everyone. So this is really the only chance to be able to get the people who need care into treatment, to be able to identify them and make sure that they're able to get treated.
I see. What's next after this? What else do you think that you can apply machine learning to for people?
Yeah, so that's really exciting. It looks like AI can see a lot of things in the retina that humans can't. So we're looking to apply it to cardiovascular disease, neurological disease, and a host of other problems that we're hoping, that the algorithm can find out with just a simple retinal image.
Awesome. Jorge, thanks for sharing your story, and thank you for the work that you're doing.
Thank you.
I'm Timothy Jordan, and this is I/O Live.
Hearing my parents playing guitar, that's probably my first memory. When I started learning about how sound waves are just vibrations in the air, my eyes opened to like a new world. And that's, I think, when it clicked that I knew I wanted to do engineering.
Daniel had a musical background. That's an important part of working on audio, is you have to have an understanding of the way sound works.
The scientists at Embari wanted to figure out a way to, in any given day, count how many blue whales there were.
So the process involves recording audio from the ocean, but it's too much information for a human to try to look at and listen to.
We were able to turn those sounds to spectrograms, which are just images of what sound looks like, and fed those images into TensorFlow, this machine learning tool.
It allows us to take a mammoth pile of data and distill it into something meaningful.
It can answer a lot of questions about the way we are affecting the marine environment and how we can help conserve it. When I was a kid, I didn't think I was going to be a scientist or an engineer, but knowing that I'll never stop learning makes me feel pretty lucky.
Welcome. Thank you for joining. Our session will begin soon.
Hi, everybody. Thanks for coming. I know you have a good selection of entertainments this afternoon, so I'm glad that so many of you chose security. Hopefully, we'll have some good fun, a little bit of fear, not too much. So today, I'm going to talk about lessons that we learned from the Spectre and Meltdown vulnerabilities. My name is Chris Palmer. I'm from the Chrome security team, and we'll be giving this talk in two parts. I'll talk about Spectre and Meltdown and how we defended against it. And then in the second half, my colleague Emily Schechter from Chrome Security will talk about what you developers can do to make the most of all the defensive work we've been doing. In addition, not just about Spectre and Meltdown, but about other good stuff on the web and for extensions too. So we'll talk about what Spectre is and why it hurts the web, what we're doing to defend against it in a way that doesn't damage the web platform itself. And we got a little close to that, as some of you may know, and I'll talk about what that was about and what we're going to do to get back to good. And then, as I was saying, there's general advances that Emily is also going to talk about. There's some good stuff there. So, you may have seen this logo. It's one of those logoed vulnerabilities. Meltdown is a variant of it that affects the operating system kernel, so we're not going to talk about that because we are focused on the web and what we have to do in sort of non-kernel space to be safe. So our concern is the open web platform. I would encourage all of you to check out the SpectreAttack.com website, which describes both attacks, the vulnerabilities, and also the Google Project Zero blog, where Jan Horn, one of the discoverers of this set of problems, goes into extreme technical depth, which I think you might enjoy. I won't get too heavy in this talk. We'll talk about what you need to know to get the impact of it. So these vulnerabilities became public in January of this year, and as a whole team of people who discovered it, people from Graz University in Austria and University of Adelaide and Rambus and independent researchers, everyone sort of had an angle on this thing. And these are hardware vulnerabilities, not software vulnerabilities. So fixing it is a different situation than a usual software patch. So we had to do a lot of work in Chrome to get through it. And it was moderately terrifying. And by moderately, I mean extremely. And by extremely terrifying, I mean don't panic. It's handled, and you can do stuff, and we did stuff, and it's going to be okay. We'll get through it. But, you know, it was a little scary. I lost some sleep. On the Chrome side, a lot of people did a lot of work to make this defense happen. I'm sort of the messenger today, but the V8 team, the Project Zero team, and there's a whole team called the Site Isolation team, and you'll be hearing about them. They did a lot of work to get us through this little adventure. And so I'm sort of presenting on their behalf, and I was just sort of the guy. They did all the real work. So the main impact of Spectre and Meltdown is the hardware has a bit of a problem where if two programs are running on the same chip, they now they can lose confidentiality guarantee from each other. One can read the secrets of the other. So that's a bad problem. The hardware is supposed to protect against that. And the way it happens is most modern hardware has a feature called speculative execution, where when you're about to branch for an if statement, for example, even before you know if the if condition is going to turn out to be true, the computer starts executing the if block, because if it does turn out to be true, then by the time you figure that out, some of the work is already done. So it's a form of small-scale parallelism, and it really helps performance a lot. It's a huge advance. And so what happens if the instructions, if the if branch is not taken? Then what? Is that work, you don't see it, it doesn't happen in your program. What happens is the computer never retires those instructions. So the work gets thrown away with no side effects on the registers or memory or anything like that. Except there's one little catch. The cache memory in the chip to speed up memory accesses, side effects of loading memory that had to be done during speculation remain. And an attacker can observe those side effects on the shared cache resource. And that can happen both within and across privilege boundaries, like across user to kernel, across from one process to another, and on the web across origins. So that's a pretty bad problem. And here's a little snippet of how this might happen. This is what we're calling a speculation gadget. It's a snippet of code that either might appear in a program naturally, or the attacker might create it, cause it to be in the program, such as with JavaScript. And this example is probably the simplest possible way to explain one variant of the attack, and there are several other variants. And this example is sort of taken from the Spectre paper. I didn't make this up. I would definitely suggest reading the paper. It's very fun. So what happens in the attack? The attacker controls X, this index to array 1, and it's out of bounds. It's beyond the boundaries of that array. And the attacker can also flush or cause to be loaded some stuff into cache memory. There's various ways to achieve that. Previous research showed how. And there's an out-of-bounds secret beyond the edge of array 1 that we'll call K that the attacker wants to learn. That's the breaking the confidentiality guarantee. And the attacker causes that to get in cache, so accessing it is fast, as opposed to accessing things out of main memory, which is fairly slow relative to the CPU's speed. So what happens here is, obviously, we're going to do a bounds check, because of course you would. That causes speculative execution. It might be the case, for example, that fetching array 1 size from main memory is going to be slow. It's not in cache, let's say. And then the computer is going to start doing that y equals array 2, and then that's when the attack happens. Because what happens is that causes that memory to get loaded into cache memory, and then accessing it later will be fast. And that gives the attacker, who can control and see array 2, the ability to determine if, for a guess n, for every possible value of x, call it n, just keep guessing in a for loop. And eventually, the attacker will see that accessing n is fast, and then they will know, or accessing n as an index of array 1 is fast, and then they will know that that's the same value as the secret. And this scales sub-exponentially, so it's actually practical to do. You don't have to guess all possible values of k. You get to guess byte by byte and then additively take time. And so the attacker can just run this in a for loop, and then they learn secrets out of bounds, stuff they shouldn't be able to read. So how do we defend against that? The hardware doesn't do what we hoped, or it does a nice thing for us with cache memory and speculation, but it has this bad side effect. So you might think, as a lot of people at first did, well, why don't we just turn off speculation? That would be great, then the problem goes away. Or what if we just didn't have cache memory anymore? Well, that's completely untenable from a performance perspective. we really need speculation, and we really need a large shared cache to have low cost, high performance. It's not really negotiable. So we have to use a smarter approach than this sort of big dumb hammer that you might imagine at first. So how does this impact the web? It had a huge impact on operating systems and hypervisors, and that's, other people are worried about that. I'm worried about the web. So the problem sort of could generalize, but I'm just going to focus on the same origin policy, which is really what we're hoping to achieve. That's our main security principle in the web. See, here's a picture of a typical renderer process. You know, Chrome has a multi-process architecture, and it's running various processes to run your various tabs. And in any one renderer process, there might be several different origins happening at the same time. In this case, we've got innocent origins A, B, and C, but there's also a hostile origin running in the same address space. And that origin can either discover or cause to be created speculation gadgets, like in the previous slide, and then it can start reading data that belong to origins A, B, and C inside the same process. So that's a loss of confidentiality across origins, which is extremely bad for the web. Like I said, I lost some sleep, but don't worry, we're going to take care of it. So the new baseline that we now operate in is just, we assume that any code running in a given address space in a given process can read the whole address space. And that's a significant change from the previous status quo. So to do the attack, though, it's not automatic. The attacker needs a couple things. They need a CPU that does do speculation, which turns out to be not all CPUs. Certain low-end ARM processors don't. So those are actually safe. But pretty much every other machine does. Every Intel desktop you've got, every iPhone, high-end Android. So the attacker gets that. You need a CPU with a shared cache, and again, every machine has that. So the attacker has that. You need a high-resolution clock so that the attacker can time the difference between accessing stuff out of cache versus accessing stuff out of main memory. The better the resolution of that clock, the easier to achieve the attack. But even fairly low-resolution clocks could still work, at least in theory. So a clock, and there's tons of clocks in the web platform. And then the presence of such gadgets, speculation gadgets, or the ability to create them, which again, obviously JavaScript lets you write whatever you want. So all the preconditions are met on the web. So to defend, the first thing we want to do is break those preconditions. So the one that came to mind, everybody, at first was like, well, let's get rid of high-precision clocks. And that's turns out to be not really feasible, unfortunately. The web platform has a whole bunch of clocks, APIs that are clocks on purpose, like performance.now. And then there are APIs that turn out to be clocks by accident, or implicit clocks, such as shared array buffer. Does everyone know what shared array buffer is? Some hands, a few. All right, well, it's a thing. It's a way to let you share data between a worker and your main thread, for example. And that turns out to be a nanosecond scale clock, because the worker can just increment a counter in the shared array buffer, and then the main thread can say, oh, hey, what's our value now? That's about how many milliseconds, or sorry, nanoseconds have passed. So it's a clock. So in order to make exploitation not be too easy, we actually did turn off shared array buffer, even shortly after shipping it, which was a real bummer for us. We did not want to do that because people need it to make cool applications on the web. And we want the web to be cool and powerful and to enable interesting applications. So we had a big old argument about whether or not we're really going to do that. But we did, and we're bringing it back, and I'll explain how. But unfortunately, I think that did gain us something. I think the easiest route to exploitation was avoided by doing that, and other browsers did similar things. And we all collaborated to sort of figure out how we're going to do this in a way that doesn't hurt the web. and so that we're all on the same page. That's actually another, I should mention that, it's kind of a happy story that comes out of this, is a really good collaboration between the security teams of a lot of different browser vendors. And it's been a great experience for all of us, and I think we're going to come out with a much better web thanks to the help of everyone. So, and we're going to bring shared array buffer back once we have made the web safe for clocks, which sounds like a funny thing to say. So, as I was sort of getting at, we don't want to lightly toy with the web platform. It has to be stable so that you can build stuff on it. If we're taking APIs away or changing how they behave, that's not a good developer experience, and that's therefore not a good user experience, obviously. So we can't do that too much, and we did not do it lightly. And going forward, our goal is to be very, very careful and ship, well, even more careful than before, and ship things that we believe that we won't ever have to unship. That's a tall order, but super bad emergencies like Spectre have sort of recalibrated our thinking as to what kinds of things are possible. And that's kind of been fun, a good adventure, frightening form of fun that I kind of enjoy. So other things we can do, like think back about that, that gadget. What if we could turn off speculation, not across the board, because that's not tenable for performance reasons, but what if we could just, like, for this if check, when checking array bounds, definitely make sure you've fully checked it before you then speculate further. You can do that, actually. Different CPU architectures have different instructions to let you say, don't go past this point until you've loaded this thing from memory, and so on. You can sort of turn off speculation on a micro scale. And the V8 team heroically worked to do as much of that as they can to get rid of speculation gadgets in the runtime and to change how they compile code to not generate any gadgets. And that is a very difficult thing, and they had to do a lot of work. And unfortunately, it doesn't get us all the way across the finish line. But it definitely, again, like turning off shared array buffer, it got us a little breathing room to get through to this point, to where we now can do more long-term things. So there's the low-level defenses, but the web needs more than just that. We've got to really do something about the origin boundary per se. We've got to uphold that thing directly. So that's what we're trying to do. So think about a malicious site that can take over a renderer, such as by memory corruption or a logic bug. That's something that we call universal cross-site scripting. And that's a bad bug, and they can cause other origins that they want to attack to be loaded in the renderer. And so we knew all along that we needed a good way to defend against that. And so years ago, we started cooking one up, and we call it site isolation. And it turns out that site isolation is super useful for Spectre also, pretty much for the same reason, because what it does is it's a rethinking of how we apportion origins to processes. In the past, it was based on like resource consumption and how busy is this renderer? Do we need a new one? Or can we reuse one that's got a light load? So now we are going to instead line up sites with their processes. They're dedicated to them. And that gets hostile origins out of our address space of innocent origins. So here's a picture of the status quo, sort of a block diagram of the technology stack. You've got your hardware, you've got kernel mode or ring 0, you've got user mode or ring 3, you've got your kernel, there's other userland processes, there's the browser, and the browser is spawning a renderer or maybe 10 to run origins A, B, C, and D, or whatever else you've got going. So that's the status quo, and we're changing that in a way that seems simple when you draw a picture, but it's an incredible amount of work. We had to fundamentally rethink basic assumptions about Chrome's architecture in order to achieve this. Navigation, JavaScript APIs, it crosses the board. It's quite interesting. So now site A, B, and C, and D will get their own renderer processes, and they'll be isolated from each other. So if D turns evil, it can only read whatever it wants using Spectre, it can only read whatever it wants out of its own process. And A, B, and C are safe elsewhere. Here's another picture of that, sort of a callback to the previous. Now you can see that hostile site is in its own address space, safely isolated from the good friends A, B, and C. So this is a great solution. We think it's the way forward for a variety of reasons. Not just Spectre, like I was saying, it's also a good defense against universal cross-site scripting. But it's not perfect. There's some limitations. For one thing, I've been saying site, not origin. A site is something that we define as being the effective top-level domain plus one label below that. So like nhs.gov.uk. .gov.uk is the effective top-level domain, NHS, one level below. Similarly, com, and then one level below, Bing, or Google, or whatever. So that's very different than the definition of an origin, which is the whole host name and the port number. And of course, for both of these, scheme matters too. You can't be the same site if you're HTTP as the HTTPS version of your site. You can't have that. So a site is the scheme and the effective TLD plus one, or eTLD. And as you can imagine, we're going to be loading or launching more processes. So that uses more memory. So unfortunately, a little more RAM is going to be required. And then last, there's a thing called cross-origin read blocking, which is a crucial part of site isolation that requires you to do a little bit of work. It's not a heavy lift, don't worry too much. And Emily will explain how you can get the most of it and why it's important. But it's a crucial thing that you'll all want to take a look at. The final thing that we're changing how we do for Spectre is before we give super important information to a renderer, like autofill form data, your passwords, payment instruments, we're going to gate that on some indication that the user, the person, really wants to do it. There won't be any sort of automatic giving of super sensitive information to renderers. So the person's going to be maybe a little more in the loop on some things than they have in the past. And I really think that's important, especially given the fact that a site, being more broadly defined than an origin, a site may contain some potentially hostile origins in its same site instance, and therefore in the same process. For example, super important thing.example.com and forgotten old WordPress installation.example.com. Those are in the same site currently. So obviously, in the long term, we'd like to get back to something closer to the origin definition. So anyway, we're going to make sure people want to do things before we give information to renderers. So there's things you can do about this, including cross-origin read blocking. And that's where Emily comes in from Chrome Security Team. And she's got some good information for you. So please give her a warm welcome. There you go.
All right. So thanks so much, Chris, for enlightening us about Spectre and for overviewing ways that we're making Chrome and the web platform safer with site isolation. So now I know all of you may be wondering what you can do about all of this. And it turns out that there are actually lots of things that you as web developers can do to best amp up your defenses. So I'll go over some steps that you should take to keep your web project secure. First, I'll talk about steps that you should take to get the most of Spectre defenses. And then I'll talk about some general security recommendations for website developers and for extension developers. So first, let's talk about the Spectre-specific defenses. And there are two specific areas that you'll want to think about as a web developer: getting the most out of cross-origin read blocking and cookie health. So I'll explain what both of these are and about how you should think about them. So first, we'll talk about the feature that Chris mentioned called cross-origin read blocking and how you can get the most of it. So Chris just talked about how site isolation will put different sites into different processes. Even when all cross-site pages are put into separate processes, pages can still legitimately request some cross-site sub-resources, such as images and JavaScript. So to help prevent sensitive information from leaking, site isolation includes this cross-origin read blocking feature that limits which network responses are delivered to the renderer process. So why does this matter? Well, imagine an attacker creating an image tag that includes a JSON file with some sensitive information, like maybe your bank balance. Without site isolation, the contents of the JSON file would make it to the renderer process's memory, at which point the renderer notices that it's not a valid image format and doesn't render the image. But now we have Spectre, and so now there's a way to potentially read that chunk of memory. So cross-origin read blocking would actually prevent the contents of this file from ever entering the memory of the process that the renderer is running, because the MIME type is blocked by cross-origin read blocking. So let's break down how this works. A website can request two types of URLs from a server: data resources and media resources. So here, data resources include text or code-like resources, so HTML, XML, JSON files. And a website is able to receive data resources from its own domain or from other domains with permissive CORS headers. So cross-site data resources come from a different site than the page that requests them, and they do not have CORS headers that would make them accessible. Media resources could include things like images or JavaScript or CSS, and media resources can be included from any site. So the cross-origin read blocking policy prevents a process from receiving these data resources from other origins if they have an HTML, XML, or JSON MIME type, and there is an X-content type options no-sniff HTTP response header, and if CORS doesn't explicitly allow access to the document. Data resources that are blocked by this policy are presented to the process as empty, although the request does still happen in the background. So here's an example for randomsite.com, where we have two cross-site sub-resources from yourbank.com, right, which might be some pretty sensitive information. So the first looks like an image, but it actually includes JSON, and it does not include a CORS header, so it will be blocked. And in the second request, it's fetching JSON, but it does include CORS. So if there is a legal access control allow origin header on the response, it will be allowed. So what this means is that to benefit from cross-origin read blocking, you need to send the right content type headers so that cross-origin read blocking can recognize the resource as sensitive and block it. And you should also tell the browser not to MIME sniff. So when no sniff is missing, Chrome does do a quick content analysis to try to confirm that the type is correct, but you're definitely better off affirmatively doing the right thing yourself. So that's cross-origin read blocking. So now let's move on to cookie health. So if we go back to our previous example, where the attacker created an image tag that includes a JSON file with sensitive data, this actually only works if your bank.com has stored a cookie that automatically logs the user in. And cookies typically get sent for all requests to the website that sets the cookie, even if the request is made by a third party using the image tag. So now we have same site cookies. They're a new attribute that specify that a cookie should only be attached to a request that originates from the same site, hence the name same site cookies. And right now, Chrome and Firefox 58+ are supporting this attribute. If your site's cookies are only used server-side, not by client JavaScript, there are ways that you can stop the cookies data from entering the renderer process. You can set the HTTP-only cookie attribute, which explicitly prevents the cookie from being accessed through a client-side script on supported browsers like Chrome. And if setting HTTP-only is impossible, you can help limit the exposure of loading cookie data to the rendered process by not reading document.cookie unless it's absolutely necessary. So that wraps up how you as a web developer should make changes to best mitigate Spectre. We have this information posted online on our Web Fundamentals article, so definitely check back there for more updates. So now that we've talked about ways to mitigate Spectre, let's talk about other ways that you can keep your web projects safe. And I say projects here because many of these methods are applicable for both websites and Chrome extensions. So there are 3 overall categories to think about improving security for your site or extension. And the first is using web security standards. So HTTPS is one of our favorite topics on the Chrome security team, so I would definitely be remiss if I didn't remind you that when sending or requesting data, you should always avoid HTTP. This is important for website developers, and it's also important for our extension developers too, right? You should never be using plain HTTP in your extension. HTTPS is just the bare minimum that web users today expect in terms of site security. And at 4 p.m. today, right after this talk, but over on stage 6, Adrian Porterfeld and Ben McElwain will be talking about amazing HTTPS adoption trends that we're seeing, and also the latest and greatest updates in HTTPS UI changes in Chrome, so be sure to go check out that talk. And of course, if you aren't using HTTPS, you can check out our setup guide to figure out how to get started. The content security policy provides a rich set of directives that enable granular control over the resources that a page is allowed to load and where they're loaded from. And this is an awesome way to help prevent cross-site scripting attacks. And there are a lot of ways that you can use the different directives and the policy violation reporting tools that you might not know about. So I recommend that you go check out our Web Fundamentals article to learn more. And extension developers, CSP is for you too. You should definitely include an explicit CSP for the extension in the manifest. So if you're using content security policy in your extension, it might look something like this. If the extension is only loading resources from itself, you can register this CSP. And if the extension needs to include scripts from specific hosts, they can be included here as well. So that's a quick primer about what you should know in terms of web security standards. And now let's move on to protecting developer accounts. So this one is actually particularly important for developers of Chrome extensions. If you're a developer of a Chrome extension, you might not realize it, but you actually now have a lot of power because your code is running on a lot of users' browsers, right? So if your developer account is compromised, an attacker could just push malicious code directly to a lot of users. So this means that you've actually become a pretty juicy target for attackers. And what this means is that you should definitely take extra care to protect your developer account. So Google released the Advanced Protection Program to safeguard the Google accounts of those most at risk of targeted attacks. It includes phishing protection with a physical security key, safeguarding your emails and files by limiting access to non-Google services, and blocking fraudulent account access with extra steps to verify that it's you. But if the Advanced Protection Program is not for you, you should definitely still take other measures to protect your accounts. For example, you should enable two-factor authentication, and preferably with a security key. So finally, I'll talk about privacy protections. And here I'll focus on permissions. So first, I'll talk about permissions best practices for web developers. And then I'll talk about permissions best practices for extension developers. On the web, when you use certain powerful APIs like geolocation or push notifications, Chrome will ask the user for permission to use that powerful API. And it's important for you as a developer to consider how you'll be asking your users for this information. In particular, if users understand the value that permission brings at the time when you ask for it. So for example, here we have a hypothetical airline web app. And you can see there's a checkbox at the bottom of the screen for user to indicate that they want notifications for flight delays. And so after a user checks this box is a really great time to ask for the push notification permission because the value of getting notifications for flight delays is really clear. And a much worse user experience would be, for example, just spamming the user on page load all the time for a bunch of permissions that might seem random at that point. So now I'll move on to some permissions best practices for extension developers. We'll cover 2 best practices: reducing required permissions and using optimal permissions. So first, reduce required permissions. The APIs an extension can access is specified in the permissions field of the manifest. And the more permissions are granted, the more avenues an attacker has to intercept information. So only the APIs that an extension depends on should be listed. Extensions that are using host permissions to inject scripts can often substitute ActiveTab instead. The ActiveTab permission will grant an extension temporary access to the currently active tab only when the user invokes the extension. And access is cut off when the user navigates away from or closes the current tab. So this serves as a good alternative for many uses of all URLs. You should also empower users to choose which features and permissions they need from an extension by including optional permissions. If a feature is not essential to the core functionality of an extension, make it optional and move the API or domain into the optimal permissions field. And here's what using optional permissions looks like in our manifest. OK, so we just covered a lot of best practices. We covered how you can take advantage of protections from Spectre. And we covered other best practices to keep your website or your extension safe using web security standards, developer account protection, and permissions best practices. At Chrome, we believe in creating a web that's easy to use securely by default, and we continue to work on security protections that make the entire web safer. So developers, go out there, take advantage of these tips and resources so that together we can continue to build a platform and an ecosystem that is safe by default for everyone. And let us know if you have any feedback on the talk, and we'll be in the web sandbox area after the talk if you have any questions. Thanks.
Thank you for joining. Remove before the action is triggered and then trigger the action. With Android KTX, we can just call do on predraw on our view and trigger the action. These are just a few of the extensions available so far. Check out the docs to find out what else we have there. If you want to suggest more ideas for extension functions and you'd like to contribute, check out the Android KTX GitHub project. We're still in preview, the API is not stable yet, so your feedback is valuable and can shape the library. This is just the beginning of Android KTX. We're working on extensions for support library and architecture components. Kotlin on Android is here to stay, and we have big plans for it. Follow us on GitHub, YouTube, and Twitter for more news.
Hello and welcome back to I/O Live. I'm Timothy Jordan and I'm standing here with Niall and with Shaza, and they built an app using TensorFlow. I'm going to talk about it a little. Niall, could you tell me what the app is and how you came up with the idea?
Sure. So the app is actually a plant classification app. You basically take your camera and hold it over a plant leaf. The app then tells you what type of plant it is. It tells you if it's healthy or if it has a disease and what the disease is. And we actually came up with it one day in lunch. So Shaza had been talking about wanting to create an app, and we were brainstorming some ideas, and I thought about my mom, who has had a huge passion for gardening. About a year ago, we ended up moving, and so she had to transport her garden from a big backyard to a tiny little patio in an apartment. Thus, all of her plants were dying. So we ended up making the app and helping her garden flourish.
Awesome. Now, Shaza, what was it like getting started with machine learning?
Hi, Timothy. I got started with machine learning through a TensorFlow code lab called TensorFlow for Poets, and I learned all about how machine learning works and how to use convolutional neural networks on your own data set using the TensorFlow API.
Did you find that challenging?
It was very challenging. It took me a long time to learn because it was my very first programming experience, but it ended up being a really amazing project.
Awesome. Now, what's next? Do you have any ideas for new apps?
Yeah, so I definitely want to do something that has to do with women in third world countries. I have a really close friend who's actually a national leader in the organization Girl Up, and so their topic is just dealing with women in third world countries. So we're definitely working together right now on something to benefit that.
Awesome. Okay, one last question. Do you have any advice for somebody out there who's looking to get started in machine learning or even just computer science?
To someone who's looking to get started in computer science, I would tell them that it's a lot easier than you think, and there are a ton of resources out there if you want to learn about machine learning or artificial intelligence.
Awesome. Thank you so much. And thank you for joining us. This is I/O Live.
Hi and welcome to I/O Live. I'm Florina Montanescu, your host, and I'm here today with Sasha Preuster, Director of Product of Android TV.
Hi, Florina.
So tell me, Sasha, what's new with Android TV?
Hey, yeah, we have a bunch of stuff that we're excited to talk specifically with developers at Google I/O, because it is a developer conference after all. So we do a lot of talks and sessions here about how TV app developers can actually integrate really well with Android TV. So as you can see on the screen, if I just scroll around a little bit, we want app developers to get their top content and like really beautiful pictures, all the metadata on screen, but we want to make sure it's not only YouTube or HBO that can do that stuff. We want every app developer can do this, right? So we talk a lot about new ways how you can do this integration really nice, what ways we have to help you with this, and basically want to enable developers to have really the best content on the TV and make the content really shine, because we want to help them to make their apps popular, right? And then obviously it's Google I/O, so we're talking about Android P as well. So we have a bunch of new stuff in Android P for users, but also for developers. So some examples for users are we have a very new like fast setup flow that gets you all your favorite apps already when you set up a device. We have features like autofill, where if you have already logged in on some other device, you already get your login credentials on Android TV, so you don't have to clumsily enter passwords with the remote control. No one likes that, right? But also there are cool new platform APIs in Android P, where, for example, with external camera support, so you could start to develop camera apps on TV as well. Yeah, and that's some of the stuff with Android P where you can use the new Android P Preview SDK. It has a TV emulator, and you can get started with that if you want.
So I know last year you launched the Assistant in the US, but I live in London. Can I finally use it in London also?
A very good question. Actually, the international support for the Google Assistant is on Android TV is rolling out as we speak. So specifically the UK and some other European countries rolled out in the next few weeks. But since you mentioned the Assistant, one really cool thing we announced here at Google I/O is our new soundbar project that we did with JBL. It's the JBL link bar that you can see here. And we really like the combination of having a TV device powering your TV screen, but with really awesome sound, and a far-field microphone built in, so you don't really need this remote control anymore. You can basically just sit on the sofa and control your TV device or any device connected to the soundbar. So you can ask things like, "Hey Google, what's my agenda today?"
Today, there's only one thing on your calendar. It's at 6 p.m. and its title is Pick Up the Dog.
Yeah, I really shouldn't forget that. But it's really nice. You don't have to get up from the couch, look for the remote control anymore. You just talk to your TV in a very natural way. "Hey Google, go home."
Okay, great, so I can continue losing my remote control. Thanks. Okay, but still, I'm an Android developer, so what can I do practically? Is there some code that I can already write?
Yeah, I mean, you could download the Android P Preview SDK with your emulator, but we know developers want to work with real hardware. So one really cool thing we are announcing here at Google I/O is the ADT2 developer device. It's for those of you who have been developing for Android TV for a while, might remember we had an ADT1 developer device in 2014, launched at Google I/O, and after 4 years we thought it's time to do that again. So it's a neat little Android TV dongle you can connect to your TV. You can sign up for this. We have a sign-up form live, and we are selecting, it's a limited edition device, but we make sure a lot of developers are getting one of those. It's a real cool, small Android TV dongle, voice-enabled remote control, so all the things we've been talking about, content integration, assistant integration for your apps, you can try that all out on the device.
Okay, great. Thank you very much, Sasha. So we already have a lot of new things for Android TV, both for developers and for end users. So now all we need to do is check out the developer documentation and also sign up for the dongle. Thank you, Sasha.
Thank you.
This is Florina for I/O Live. To make Android development with Kotlin more clear, pleasant, and idiomatic when working with Android framework classes, we created Android Kotlin extensions, a set of extensions to the framework that cover some of the most commonly used classes like Vue, Shared Preferences, Canvas, Animator, and others. For now, Android KTX is in preview, and the API is likely to change before reaching the stable version. But here's how to integrate it in your projects to check it out, some examples of usage, and how you can contribute. In the build.gradle file of our app, add the Google repository, if it's not there already, and then add the Android KTX library to your dependencies. Let's start with a simple example. Let's say that we want to create a URI from a string. Normally, you would call URI.parse on the string, but with Android KTX, we can just call toURI on the string. When we want to save a value in Shared Preferences, our code would look like this. We edit the preferences, put the value, and then call apply. With the extension, we just need to call edit and pass a Lambda block with the action. Under the hood, it actually does the same thing as the previous code. Working with classes from the graphics package, we've added extension functions for some of the most important classes there: Canvas, Bitmap, Path, Color, and others. So let's say that we want to draw the difference between two paths offset downwards by 100 pixels. First, we get the difference of the paths. Then we translate the canvas, and afterwards we draw the new path. All of this code can now be simplified like this. Okay, let's take another example, this time with a view, and say that we want to execute an action before the view is drawn. The default implementation requires us to add an onPredraw listener, make sure it's removed before the action is triggered, and then trigger the action. With Android KTX, we can just call doOnPredraw on our view and trigger the action. These are just a few of the extensions available so far. Check out the docs to find out what else we have there. If you want to suggest more ideas for extension functions and you'd like to contribute, check out the Android KTX GitHub project. We're still in preview, the API is not stable yet, so your feedback is valuable and can shape the library. This is just the beginning of Android KTX. We're working on extensions for support library and architecture components. Kotlin on Android is here to stay, and we have big plans for it. Follow us on GitHub, YouTube, and Twitter for more news.
Hello and welcome back to I/O Live. I'm Timothy Jordan and I'm standing here with Niall and with Shaza, and they built an app using TensorFlow. I'm going to talk about it a little. Niall, could you tell me what the app is and how you came up with the idea?
Sure. So the app is actually a plant classification app. You basically take your camera and hold it over a plant leaf. The app then tells you what type of plant it is. It tells you if it's healthy or if it has a disease and what the disease is. And we actually came up with it one day in lunch. So Shaza had been talking about wanting to create an app, and we were brainstorming some ideas, and I thought about my mom, who has had a huge passion for gardening. About a year ago, we ended up moving, and so she had to transport her garden from a big backyard to a tiny little patio on an apartment. Thus, all of her plants were dying. So we ended up making the app and helping her garden flourish.
Awesome. Now, Shaza, what was it like getting started with machine learning?
Hi, Timothy. I got started with machine learning through a TensorFlow code lab called TensorFlow for Poets, and I learned all about how machine learning works and how to use convolutional neural networks on your own data set using the TensorFlow API.
Did you find that challenging?
It was very challenging. It took me a long time to learn because it was my very first programming experience, but it ended up being a really amazing project.
Awesome. Now, what's next? Do you have any ideas for new apps?
Yeah, so I definitely want to do something that has to do with women in third world countries. I have a really close friend who's actually a national leader in the organization Girl Up, and so their topic is just dealing with women in third world countries. So we're definitely working together right now on something to benefit that.
Awesome. Okay, one last question. Do you have any advice for somebody out there who's looking to get started in machine learning or even just computer science?
To someone who's looking to get started in computer science, I would tell them that it's a lot easier than you think, and there are a ton of resources out there if you want to learn about machine learning or artificial intelligence.
Awesome. Thank you so much. And thank you for joining us. This is I/O Live.
Hi and welcome to I/O Live. I'm Florina Montanescu, your host, and I'm here today with Sasha Preuster, Director of Product of Android TV.
Hi, Florina.
So tell me, Sasha, what's new with Android TV?
Hey, yeah, we have a bunch of stuff that we're excited to talk specifically with developers at Google I/O, because it is a developer conference after all. So we do a lot of talks and sessions here about how TV app developers can actually integrate really well with Android TV. So as you can see on the screen, if I just scroll around a little bit, we want app developers to get their top content and like really beautiful pictures, all the metadata on screen, but we want to make sure it's not only YouTube or HBO that can do that stuff. We want every app developer can do this, right? So we talk a lot about new ways how you can do this integration really nice, what ways we have to help you with this, and basically want to enable developers to have really the best content on the TV and make the content really shine, because we want to help them to make their apps popular, right? And then obviously it's Google I/O, so we're talking about Android P as well. So we have a bunch of new stuff in Android P for users, but also for developers. So some examples for users are we have a very new like fast setup flow that gets you all your favorite apps already when you set up a device. We have features like autofill, where if you have already logged in on some other device, you already get your login credentials on Android TV, so you don't have to clumsily enter passwords with the remote control. No one likes that, right? But also there are cool new platform APIs in Android P, where, for example, with external camera support, so you could start to develop camera apps on TV as well. Yeah, and that's some of the stuff with Android P where you can use the new Android P Preview SDK. It has a TV emulator, and you can get started with that if you want.
So I know last year you launched the Assistant in the US, but I live in London. Can I finally use it in London also?
A very good question. Actually, the international support for the Google Assistant is on Android TV is rolling out as we speak. So specifically the UK and some other European countries rolled out in the next few weeks. But since you mentioned the Assistant, one really cool thing we announced here at Google I/O is our new soundbar project that we did with JBL. It's the JBL link bar that you can see here. And we really like the combination of having a TV device powering your TV screen, but with really awesome sound, and a far-field microphone built in, so you don't really need this remote control anymore. You can basically just sit on the sofa and control your TV device.
There's nowhere else you wanna be, right here, right now, here and now. There's nowhere else you wanna be, right here, right now, here and now.
A lonely road, I can't believe I'm on it solo. Half of a whole, what if I'm too afraid to let go? Let go. And don't try to tell me now how you think I missed out. Don't try to bring me down. It's time we get out this town. Rise up, 'cause I can't go on hoping this thing ain't working out. Rise up, 'cause I'm already growing, and this thing can't stop me now.
Okay. Hello, everyone. I'm Matthew, and this is my colleague, Colleen. And today we're going to be going over what's new with the Android runtime on Android, also known as ART. So, what is ART? Well, ART is the software layer in between the applications and the operating system. It provides mechanisms for executing Java language and Kotlin applications. To accomplish this, ART does two things. It executes DEX files, the intermediate representation of Android applications, through a hybrid model consisting of interpretation, just-in-time compilation, and profile-based ahead-of-time compilation. ART also does memory management for Android applications through an automatic reclamation through a garbage collector. This is a concurrent compacting garbage collector so that there's less jank for your applications. Now, let's look at how ART has changed over the last few years. Over the years, there have been many improvements to ART. In Nougat, we introduced profile-guided compilation to improve application startup time, reduce memory usage, and reduce storage requirements. Also in Nougat, we added a JIT, much like Dalvik used to have. This was done to remove the need for optimizing apps. That was kind of a big problem during Android system updates. And in Oreo, we added a new concurrent compacting garbage collector to reduce RAM requirements, have less jank, as well as accelerate allocations. As you can see here on the slide, this new garbage collector enabled a new bump pointer allocator that is 17 times faster than the allocator in Dalvik, or in KitKat. Now, we talked about what happened in the past, but what's new in Android P? First of all, there are new compiler optimizations to help accelerate the performance of Kotlin code in Android. This is especially important since Kotlin is the first-class programming language for Android development. Next up, we have memory and storage optimizations to help entry-level devices, such as Android Go devices. This is important to help improve the performance for the next billion users. And finally, we have cloud profiles. Device-collected profiles from the just-in-time compiler are uploaded and aggregated in the cloud to enable faster performance directly after installation of applications. Okay, so let's start with Kotlin. Last year, we announced Kotlin as the first class officially supported programming language for Android development, and then we began to investigate the performance. Why Kotlin, you might ask? Well, Kotlin is a safe, expressive, concise, object-oriented language that is designed to be interoperable with Java language. The reason ART focuses on optimizing Kotlin so that the developers can leverage all of these language features while still having fast and jank-free applications. Let's see how Kotlin optimizations are normally performed inside of the Android runtime. Usually, optimizations are performed in an investigative manner, and there's an order of preference for fixing performance issues so that the most amount of Kotlin applications can actually benefit from the optimization. The preferred option is fixing a performance issue inside of Kotlin, and Kotlin is the compiler developed by JetBrains. Google and JetBrains, of course, work closely together on all kinds of optimizations and fixes for issues. If we fix a performance issue here, it'll be able to be deployed to the most amount of Kotlin applications. Alternatively, if that doesn't work, then we consider fixing the performance issue inside of bytecode converters. Fixing in the bytecode converter will enable existing versions of the Android platform to get the performance fix. And if that option doesn't work, the last option is to fix the performance issue in the Android runtime, also known as ART. So the reason that we might not want to fix an ART right away is because ART is updated as part of the Android platform. So that means that not all devices will get the fix. Now, let's look at an example. One example of the Kotlin optimization is the parameter null check. As you can see here, this is a simple method that just returns the length of a string, but the string is nullable. So what this means is that the compiler inserts a null check into the function bytecode to actually verify that the string is not null and throw the corresponding exception if required. Implemented in the bytecode, the first step is loading the name of the parameter and then invoking a separate function to do the actual null check. So there's some extra overhead here, as you might see, because the invocation, in the common case, you do the extra invocation that goes to the function to do the null check. And this function, in turn, if required, calls the third function to throw the actual parameter is null exception. Checks such as these are commonly required for Java language and Kotlin interoperability because Java language does not have a non-nullable property. Now, let's see how we can optimize this. If we look at the bytecode, one of the first things we can do is actually inline the method that does the null check into the caller. After inlining, this improves performance because there's one less invocation. And from here, you can see one other thing we can do is that the name of the parameter is not actually required unless the argument is null. So from here, we can do code syncing to move loading of the parameter name inside of the conditional. So overall, these two optimizations help performance by removing one invocation and one loadings of a string literal. Apart from this optimization, we also track Kotlin performance on various benchmarks. Other improvements here include improved auto-vectorization of loops, also intrinsic methods that are specifically tailored for Kotlin code to help improve performance there. So the ART team is always working on improving this performance. OK, now that we're done Kotlin, what about memory and storage improvements? So since ART is responsible for Java language and Kotlin applications, it's also pretty important to just kind of make sure that the programs don't use too much memory and take too much space on the device. There have been several improvements focusing on this area, including reducing the amount of space and memory usage required by DEX files. Now, why are RAM and storage optimizations important? Well, recall last year, we introduced a new initiative called Android Go, aiming at running the latest versions of Android on entry-level devices. Since these devices typically have 1 GB or less of RAM and 8 GB or less of storage, it's kind of important to focus on optimizing these areas so that the users can run enough applications and install as many applications or more applications than they would otherwise be able to. Now, this isn't just for Android Go. Premium devices also benefit from optimizations in these two areas, but since they have more resources, normally it's to a lesser degree. Anyways, before we talk about RAM and storage optimizations, let's do a little bit of a review about how applications work on your Android devices. An application normally comes in an application package kit, also known as an APK. Inside of the APK, there are usually one or more Dalvik executable files, also known as DEX files, that contain instructions that ART uses to either interpret or compile your application. Since DEX files are required to be quickly accessed during execution, they are mapped directly into memory during application startup so that ART can have quick access. This means that there is a startup cost as well as a RAM cost proportional to the size of the DEX file. Finally, DEX files are usually stored twice on the device. The first place they are stored is inside of the application package kit, and then the second place they are stored is in an extracted form so that ART can have faster access during application startup without needing to extract from the zip file each time. Now, let's take a closer look at the contents of DEX files. Within a DEX file, there are several sections containing different types of data related to the applications. But where's the space going in the DEX file? One way to do this is you can kind of calculate where the space is going for each DEX file and average out the results. This chart here is for the top 99 most downloaded applications in the Play Store, and you can see that the largest section is the code item section containing the DEX instructions used by ART. The next largest section is the string data section, and this section contains the string literals loaded from code, method names, class names, and field names. Combined, these two sections are around 64% of the DEX file, so they're pretty important areas to optimize. Let's see if there's a way we can reduce the size of these sections. One new feature introduced in Android P is called Compact DEX. The goal of Compact DEX is simple: reduce the size of DEX files to get memory and storage savings on the device. From the previous slide, we saw that some sections are larger than others. So it's important to just focus on the large sections to get the most savings. For the code items, they are more often deduplicated, and they also have their headers shrunk to save space for each method essentially inside of the application. And another thing here worth noting about the string data is that large applications frequently ship multiple DEX files in their APK because of DEX format limitations. Specifically, the 64K method limit means that you can only have 64,000 kind of method references in a single DEX file before needing to add another one to your application. And every time you add another DEX file, this causes duplication, specifically of string data, that could otherwise be stored only once. Compact DEX shrinks this by providing deduplication across the DEX files in the APK. Now, let's go to the generation process. First, let's look at how DEX files are processed on Android Oreo. The first step, run by DEX2O, the ahead-of-time compiler, is that the DEX files are extracted from the APK and stored in a VDEX container. The reason they are extracted, as I mentioned earlier, is so that they can be loaded more efficiently during application startup. One other thing here worth noting is the profile. So the profile, as introduced in NuGot, is essentially data about the application execution, including which methods are executed during startup, what methods are hot, so compiled by the JIT compiler, and what classes are loaded. On Oreo, we're already optimizing the DEX files stored in the VDEX container by applying layout optimizations. And also, we were deciding which methods to compile based on what methods are hot in the DEX file. Now, let's look at DEX processing on Android P. In Android P, the ahead-of-time compiler now converts the DEX files to a more efficient compact DEX representation inside of the container. One new addition here is the introduction of a shared data section. Specifically, data that's present in multiple DEX files will be in the shared data section only once, so it kind of deduplicates data that's commonly shared. And one of the most commonly shared things here is the string data. So this is how we reduced the large string data section that we saw earlier. Finally, since the conversion is automatically done on device, this means that all existing applications can get the benefits of compact DEX without needing to recompile their APKs. OK, so let's look at one example of how we actually shrink the DEX code items. Apart from the instructions, each code item has a 16-byte header, and then most of the values in the header are usually small values. So what we do here is we shrink the fields in the header to be 4 bits each, and then we have an optional pre-header to extend them as required. The pre-header is 0 bytes in most of the cases, but can be up to 12 bytes in the worst case. So other than the pre-header, we also shrink the instruction count. Since the average method is not going to be that large, we shrink this down to 11 bits instead of 32 bits, and we use the 5 remaining bits for flags that are art-specific. Finally, we move the debug information into a separate space-efficient table to help enable more deduplication of the code items. Overall, this optimization saves around 12 bytes per code item in the compact DEX file. And here are the results for the top 99 most downloaded APKs. So the average space required by the DEX files on a device is around 11.6% smaller. And then also, other than the storage savings, we also get memory savings because the DEX files are resident in memory during application usage, at least partially resident in memory. And one more thing here, let's go over the layout optimizations a little bit. So even though we had introduced the JIT profiles in Android N, we did not have any layout optimizations back then. So what this means is the DEX is kind of randomly ordered and not disregarding the usage pattern. In Android O, we added this type of layout optimization that groups the methods used during application startup together and the methods that are hot. So that means their code is frequently accessed during execution together. This seems like a pretty big win so far. But let's see what we did for Android P. In Android P, we have more flexible profile information, which enables us to put the methods that are used only during startup together. This helps reduce the amount of memory used because the application or the operating system can remove those pages from memory after startup. We also put the hot code together since it's frequently accessed during execution. And finally, we put the code that just never touched at all during execution at the end so that it's not loaded into memory unless required. And the reason that these layout optimizations are important is because they improve locality and reduce how many parts of the DEX file are actually loaded into memory during application usage and startup. So if you improve the locality here, you can get startup benefits, memory reduction, and a reduction in memory usage. And now to Colleen for cloud profiles.
Thank you, Matthew. Hello, everyone. My name is Colleen, and I'm here today to present you how we plan to improve and scale up the Android runtime profiling infrastructure. However, before we start, profiling is a rather overloaded term. When we will speak about profiling in today's presentation, we're going to refer to the metadata that the Android runtime captures about the application execution, metadata that are going to be fed into a profile-guided optimization process. We're going to see how we extend the on-device capabilities in order to drive performance right at install time. Before we jump into what is new and how actually it works, let me briefly remind you how Android uses profile-guided optimizations. This is an efficient technique that we introduced in Android Nougat as part of a hybrid execution model. Hybrid means that the code being executed can be in 3 different optimization states at the same time. The primary goal of this technique is to improve all key metrics of the application performance. We're talking about faster application startup time, reduced memory footprint, a better user experience by providing less junk during usage, less disk space used by the compiler artifacts, which means more disk space for our users, and nonetheless an increased battery life. because we do heavy optimizations when the device is not used rather than at the use time. How does this work? It all starts when the Play Store installs the application. But first, we do very, very light optimizations, and we have the application ready to go for the user. At first launch, the application will start in what we call an interpretation mode. As the runtime executes the application code, it discovers the most frequently used methods and the most important methods to be optimized. That's when a JIT system kicks in and will optimize that code. During this time, the JIT system also records what we call a profile information. This profile information essentially encapsulates data about the methods that are being executed and about the classes that are being loaded. Every now and then, we dump this profile to disk so that we can reuse it later. Once the device is put aside and is not in use, a state which we call idle maintenance mode, we're going to use that profile to drive profile-guided optimizations. The result is an optimized app which will eventually replace the original state. Now, when the user relaunches the app, it will have a much snappier startup time, a much better steady-state performance execution, and overall, the battery will drain less. In this state, the application will be interpreted, just-in-time compiled, or pre-optimized. Now, just how efficient is this technique? We gather some data from the field for Google Maps application. Here you can see two charts. The left one presents data from a Marshmallow build. You can see that the startup time is pretty constant over time. It does not fluctuate. And this is pretty much expected. You don't want to have deviations here. However, on the right-hand side, you can see that in Nougat, the startup time drops over time. Eventually, it stabilizes of being about 25% faster than it used to be at install time. And this is great news. It means that the more the user uses the app, the more we can optimize it. And over time, the performance gets better and better. This is great, but we can do better, and we want to do better. We shouldn't need to wait for optimal performance. And our goal with Cloud Profiles is to deliver near optimal performance right after install time, without having to wait for the application to be profiled. So let's see how this is going to work. Let me introduce you the idea of Cloud Profiles. This is based on two key observations. First one is that usually apps have many commonly used code paths that are shared between a multitude of users and devices. Take, for example, classes loading during startup time. Each device will have its own specific set. However, globally, we can extract a common intersection of all those classes. And that's valuable data for us to optimize upon. Second, we know that most app developers roll out their apps incrementally, starting with alpha, beta channels, or, for example, 1–2% of their user base. And the idea behind Cloud Profiles is to use this initial set of alpha, beta channel users to bootstrap performance for the rest of the users. So how is it going to work? Once we have an initial set of devices, we're going to extract the profile information about your APK from those devices. We're going to upload that information to Play, and there we're going to combine everything. We're going to aggregate whatever comes in, and we're going to generate what we call a core application profile. This core profile will contain information which is relevant across all device executions, and not just a single one. When a new device requests for that application to be installed, we're going to deliver this core profile alongside the main application APK to the device. Locally, the device will be able to use that data to perform profile-guided optimizations right at install time. That will deliver an improved cold startup performance and much better steady-state performance over time. Now, having profiles in the cloud offers much more opportunities than directly influencing the app performance with profile-guided optimizations. The core profiles offers valuable data, for example, for developers to act upon. And we believe there is enough information there so that developers can tune their own applications. We're going to explore how we can share this data later. Now you can see in this workflow that to deliver such a thing, we need support from Android platform and Play alike. In today's presentation, we're going to focus on the Android support. So what did we do in P to support this lifecycle? We added new interfaces that will allow us to extract the profile and bootstrap the information from the cloud. The functionality is available to all system-level apps, which acquire the necessary permissions. And in our case, Play is just a consumer. The two APIs I'm talking about are profile extractions, and these are exposed via a new platform manager. We call it Art Manager. The second API is profile installation. And this is seemingly integrated in the current installer session. What we did here is to add a new kind of installation artifact that the platform understands. We call these DEX metadata files. Essentially, in a similar way to the APKs, the DEX metadata files are archives which will contain information in how the runtime can optimize the application. Initially, these DEX metadata files will contain the core profile that I mentioned about earlier. But install time, Play will deliver these files, if they are available, to the device, where they will be streamlined into the DEX optimizer on device. It is worthwhile mentioning that we will offer support for Google Play Dynamic Delivery. So if you plan to split the functionality of your application in different APKs, all the APKs will have their own text metadata files. So let's take a look how everything fits together from the device perspective. You remember that I presented this diagram in the beginning, showing how the profiling works locally. Let's focus here just on the profile file and on the application. Once we manage to capture a profile file, we're going to upstrip this information to Play. On Play, as I mentioned, we'll aggregate this data with many, many other profiles. And when we have a core profiles, we're going to deliver it to our new users as a core profile. The idea of the core profile is not to replace on-device profiling. It's only to bootstrap the profile optimizations. So essentially, instead of starting with a completely blank state about your application, we already know what are the most commonly executed code paths, and we'll be able to start the optimizations from there. So now, essentially, what was a pure on-device profile feedback loop, it gets extended with a cloud component. Now, I keep talking about this core profile, and I think it's important to dedicate a bit more attention to it. So let's talk a bit how we're going to build it. We already know that on device, from one execution to the other, the profiles aggregate quite well. They reach a stable point pretty fast. That means that we will not re-optimize the application over and over and over again. After a few optimization steps, we'll stop. However, that's data from one device. How well does this work when you try to do it cross devices? How many samples you would need in order to get to a robust, reliable profile? We looked at our own Google applications and we tried to figure that out. Here you can see a plot which represents the amount of information in the core profiles relative to the total number of aggregations. The y-axis represents the amount of information, and the actual value, numeric value, is not important there. What is important from this graph is that actually from 30 kind of number of profile aggregations, the information in the profile reaches a plateau. And that's very important. It sends a very important message. It means that the alpha-beta channel users will provide us with enough data to build the core profile. And it means that the majority of the production users of your application will always have the best possible experience. So how do we actually aggregate the information? I mentioned before that in the profile, you will find information about classes and methods. On device, this is roughly how it looks like. We're going to take all the executions that we have seen before, and we'll create a union of everything that we've seen. In the aggregated profile, you will have information about classes, methods, about everything that you've seen. On cloud, however, we don't really want everything. We only want the commonly executed code paths. And what we are doing, instead of having a union, we'll be having a smart intersection. We'll be only keeping the information relevant to all executions, meaning we're going to filter out all the outliers. The result is what we call the core profile, which only keeps the most commonly seen samples. And this is what's going to get eventually to the device. How well does this work? Let's look again at data captured from Google Apps. We tested this across a variety of applications, and here are the results of some representative ones. In this set, you can find application which relies on native code, for example, Google Camera, or applications which are much more Java-oriented, say Google Maps or Google Docs. For Google Camera, for example, you get a startup time improvement of about 12.6%. And that's excellent, given that the application itself doesn't have a lot of Java code. However, for maps or docs, which are heavily Java-based, you can see that the optimizations improves the startup time by about 28% or 33%. Across the board, you can see an average of about 20% improvement. And that obviously depends on what the application is doing, how much Java code is being used, and so on. Now, I mentioned in the beginning that besides improving the application performance directly via profile-guided optimizations, the profile also offers much more opportunities. I'm going to present a short use case study and walk you through some important aspects that the profiles can reveal about your application. During this use case study, I'm going to focus on a single question. Are you shipping unnecessary code to the clients? Are you? Let's take a look at some data. Again, this case study reflects the state of some Google apps that we tested. We see that on average, we profile about 14–15% of the code, and about 85% of the code remains unprofiled. When you spread the distribution, you can see, for example, that in some apps, 5–10% of the code gets profiled. In some other apps, even 50% of the code gets profiled. And this is a rather intriguing result. And the reason for that is that if the code is not profiled, that most likely means that it might not have ever been executed. Obviously, that's for a good case. I mean, the code, for example, can be unexpected error code paths, right? We all want the applications to be reliable and robust, and the error handling must be there. Hopefully, it never gets executed. You may have backwards compatibility code, support for previous API level, and such. You may have features which are not used on all devices. You may have features very targeted. And you might also have a lot of unnecessary code lying around, maybe by including libraries that you don't really use. Now, it's a bit hard to break down the percentage for these categories, and there can be other reasons why we didn't profile the code. But the skewed distribution here is a strong indication that there is a lot of room to be improvements for APK. The code can be reorganized or trimmed down for better efficiency. For example, Google Play introduced dynamic delivery schemes, which may help you reduce the code that you share by targeting features only to certain users. And that's something that you might want to look at and take advantage of. So we believe that there is quite a bit of unnecessary code lying around, at least in our own APKs. Now, since we focus on the code that actually doesn't get profiled, okay, is there anything that we can extract out of the profile code? To understand this, let me talk a bit about different categories of profile code. When the application code is being profiled, the runtime will try to label it depending on its state. And you will have a label for the startup category, for the post-startup category, and for the hot category. Obviously, these are pretty self-explanatory. The hot category of the code is essentially what the runtime sees to be the most important part of your code. It's important to keep in mind that these are not disjoint. Say, for example, that a method foo is being executed. This can be executing during startup, can be executing during post-startup time, and can also be marked as hot. For example, if you have a very heavy computation during that method. Now, if you know the code which is executing during startup time, if you focus on that, you'll be able to lower the startup time of the application. As such, the first impression that the users will have upon your application will be very good. If you look at the post-startup code, that will help you, for example, lay out the application text bytecode. That will lead to memory improvements and will be much smoother on low-end devices. As for the hot code, this is the code that should get the most attention for your optimizations efforts. It's the code that is most heavily optimized by the runtime. And it might be so because the runtime identifies that it would be very beneficial to invest time there. And it's what, if you, for example, start to try to improve the quality and the performance of your app, this is where you should spend your effort or your initial effort. Now, for this is important, like how much code of your application is actually being marked as hot. Because if everything is hot, then everything can be optimized. So that's not really useful. Let me show you the breakdown of these three categories. In this graph, you can see on the red columns the percentages for the profile code and the not profile code. This will sum up to 100%, and it's what I showed you earlier. They are here just for the reference. The blue boxes show the percentages of the startup code, the post-startup code, and the hot one relative to the total DEX bytecode. So don't expect it to add 100%. Also, one piece of code can be in different categories at the same time. As you can see here, the average, on average, about 10% of the application DEX bytecode is being marked as hot. And this indicates that when you focus on your app optimizations, you can dedicate the attention only starting with just a small part of your application code base. You obviously should spend time on all the other parts as well. But probably this is where you should start from. With this, let me go over a quick review of what we presented today and the main benefits. We started with Kotlin, and we described a few new compiler optimizations that we added that focus on Kotlin performance. We described briefly how we approach Kotlin optimizations, and that we first try to seek improvements in the Kotlin compiler. We moved to memory and storage optimizations, and my colleague Matthews introduced you to the concept of compact DEX. This is a new DEX format available just on device, and which focuses on the memory savings. And finally, I presented you the idea of cloud profiles. And we talk about how we can bootstrap the profile-guided optimizations using a small percentage of alpha-beta channel users in order to lead important performance improvement right after install time for the majority of the production users. With this, I'd like to thank you for your attention and for your presence. And I want to invite you all to Android Runtime office hours tomorrow, where we can answer any questions that you have about today's presentation or about the runtime in general. We're going to be at 5:30 in section A. Thank you so much.
There's now a more complex view to understand at a greater detail of different subscription states, subscriber states, and how you benchmark retention for your app versus other apps as well. You can look at new metrics like average revenue per user. There's new data about the acquisition and user retention funnel. There you can also compare your stats for your app against a benchmark for peer apps that are functionally similar. So all of these things hopefully help developers discover opportunities that can enable them to grow and be successful on Play.
Awesome. So we have the app model. Tell me again the link.
Yeah, so it's the Android app bundle, and you can find it at g.co/Android app bundle.
Okay, perfect. Lots of new things for developers, but also for the business side. Thank you, Matt.
Thanks, and have a great I.O.
This is Florina for I.O. Live.
We're introducing Android Jetpack, our next generation of components and tools, along with architecture guidance designed to help you accelerate your Android development. You told us it was hard to do backwards compatibility, so we built the support library. You told us it was hard to manage your app as data changes, so we built the architecture components. And we heard you wanted more, so we're building more.
Android Architecture Components gives us a template to write production-ready Android code, which helps us onboard new developers faster.
Jetpack is made up of components in 4 categories: foundation, architecture, behavior, and UI. Each component is individually adoptable and built to maintain backwards compatibility.
Android architecture components are very modular, so we're allowed to pick and choose what feature sets we want that are applicable to our app.
Lifecycle-aware observers and observable components allow for a separation of concerns that create testable, robust, high-quality apps.
One of the most important things that we don't have to worry about is what code goes where. So that helps us unit test the view models. It helps us build robust code. We do not have to be lifecycle aware, and just helps the new devs come in and then write a proper modularized production-ready code without having to add all of these extra defensive checks.
It also takes advantage of Kotlin language features that make you more productive. Jetpack manages tedious activities like persistence, background tasks, navigation, and lifecycle management, so you can eliminate boilerplate code and focus on what makes your app great.
Database persistence has been a nightmare for the Android community for years, and Room is a huge improvement. And Room was thought out with testability in mind, so we're able to add test coverage that we weren't able to before on our persistence layer without having to build any infrastructure around that.
With Android Jetpack, we're eliminating whole classes of issues and making your code easier to maintain.
Since Zillow has been using Android Architecture Components, users have been experiencing a lot less bugs in the app.
We'll keep adding new functionality to Jetpack across the entire Android surface. It's easy to get started. You can update your own app at your own speed, and all these components will work on older versions of the platform. Learn more and get started at developer.android.com/jetpack.
Hello and welcome to I/O Live. I'm Florina Montanesco, your host, and I'm here with Matt Henderson from Google Play. Hello, Matt.
Hi, super excited to be here.
So tell me, what's new in Google Play for developers?
There's tons of new stuff launching this year, broadly speaking in 3 areas. So we've got a whole new format, a new app model that's launching today. We've also got a bunch of new features that help developers to do testing and prevent bugs in their apps. And we also have some features launching today which help developers to manage their business and to grow their business on Play.
Okay, this new app model sounds interesting. Can I hear more about it?
Yeah, so there's really 2 new different things that we're launching within the app model. So one is the Android App Bundle, and that's a new format, a publishing format that a developer can use that enables them to reduce the size of their app. With the Android App Bundle, makes use of a Play technology, Play dynamic delivery, and together it serves the optimal APK for a user's given device. And so it optimizes for the user's specific CPU architecture of their device, it optimizes for the screen densities, it optimizes for the user's languages that they speak as well. And so by only sending the parts of the bundle that the user actually needs, it means that the APK that goes to the device is a lot smaller, and that in turn enables much better install conversion rates, enables lower uninstall rates, because when the app sizes are too big, users react badly. And so that's something we're launching today that I think is going to be a big win for developers.
So what do I need to do to already use this?
So if you go to g.co/Android App Bundle, you can learn more, and there you can learn how to get started. You can make use of the Android Studio 3.2 Canary that is released today, and with that you can take any app, you can move it to the app bundle format. You don't need to refactor your code. It's very easy and straightforward, and you can learn more at that g.co/Android App Bundle.
Cool. And you also mentioned something about testing.
Yeah,
Tell me more.
So, you know, as developers, you'll have noticed if you're during the release process, it's a time of risk because you can have bugs going out with a new release. And we have new testing track features that help to reduce that risk. And so you can now use Play Publishing for testing and sending out the APK to up to 100 internal dog food testers. So that's the internal testing track. We also now have multiple testing tracks for closed betas. And then also to help you reduce the bugs in your apps and improve app quality, there's some new features in Android Vitals and new features in the pre-launch report. In Vitals, we have new metrics like app startup time. We've also launched a new overview page in Vitals that draws your attention to anomalies. If some of the Vitals metrics are particularly bad, then it'll highlight those to you so you know which ones to prioritize. With the pre-launch report, so that is the automated crawler that tests apps prior to them going into production. And we've launched some new features today that enable you to reach further into the corners of your app that the crawler might not have otherwise reached. Features like a developer can do record scripts in Android Studio that help the crawler to go into particular parts of the app. Game developers, if you use OpenGL, you can create demo loops that help the pre-launch report crawler to reach different parts of your app as well. And so all these features will mean that once your app hits production, it's been much more scrutinized, eliminating more of these bugs. You know, I mentioned as well, we've got these business features. So developers are increasingly, marketers, product managers, all sorts of roles within the organization are using the Play Console, many of them to take advantage of these business features. And we're launching a new app dashboard in the console which summarizes a range of different statistics. It's, I think, much easier at drawing the user into the most important metrics. You can also configure the page now depending on which ones are priorities for you. And we have some new business stats that we're launching as well. For subscription developers, if you have a subscription model, there's now a more complex view to understand it at a greater detail of different subscription states, subscriber states, and how you benchmark retention for your app versus other apps as well. You can look at new metrics like average revenue per user. There's new data about the acquisition and user retention funnel. There you can also compare your stats for your app against a benchmark for peer apps that are functionally similar. So all of these things hopefully help developers discover opportunities that can enable them to grow and be successful on Play.
Awesome. So we have the app model. Tell me again the link.
Yeah, so it's the Android app bundle, and you can find it at g.co/Android app bundle.
Okay, perfect. Lots of new things for developers, but also for the business side. Thank you, Matt.
Thanks, and have a great I.O.
This is Florina for I.O. Live.
We're introducing Android Jetpack, our next generation of components and tools, along with architecture guidance designed to help you accelerate your Android development. You told us it was hard to do backwards compatibility, so we built the support library. You told us it was hard to manage your app as data changes, so we built the architecture components. And we heard you wanted more, so we're building more.
Android Architecture Components gives us a template to write production-ready Android code, which helps us onboard new developers faster.
Jetpack is made up of components in 4 categories: foundation, architecture, behavior, and UI. Each component is individually adoptable and built to maintain backwards compatibility.
Android architecture components are very modular, so we're allowed to pick and choose what feature sets we want that are applicable to our app.
Lifecycle-aware observers and observable components allow for a separation of concerns that create testable, robust, high-quality apps.
One of the most important things that we don't have to worry about is what code goes where. So that helps us unit test the view models. It helps us build robust code. We do not have to be lifecycle aware, and just helps the new devs come in and then write a proper modularized production ready code without having to add all of these extra defensive checks.
It also takes advantage of Kotlin language features that make you more productive. Jetpack manages tedious activities like persistence, background tasks, navigation, and lifecycle management, so you can eliminate boilerplate code and focus on what makes your app great.
Database persistence has been a nightmare for the Android community for years, and Room is a huge improvement. And Room was thought out with testability in mind, so we're able to add test coverage that we weren't able to before on our persistence layer without having to build any infrastructure around that.
With Android Jetpack, we're eliminating whole classes of issues and making your code easier to maintain.
Since Zillow has been using Android Architecture Components, users have been experiencing a lot less bugs in the app.
We'll keep adding new functionality to Jetpack across the entire Android surface. It's easy to get started. You can update your own app at your own speed, and all these components will work on older versions of the platform. Learn more and get started at developer.android.com/jetpack.
Hi. Welcome to our talk, Drawn Out How Android Renders the UI. It was almost called something else. We called it this, and then somebody in some administration position decided it was actually going to be called How to Optimize Your App for Top Rendering Performance or something. That wasn't what the talk was about, so fortunately we changed it back. Instead, we're going to tell you the details of how actually stuff works. I'm Chet Haas, I'm from the Android Toolkit team.
And I'm Romain Guy, I'm on the Android Framework team, and I do real-time graphics.
And that's kind of what we're talking about today. So we have given versions of this talk before, and we thought we were done, and then we realized that enough stuff has changed inside the system that maybe it was time to go through this again and see where we're at. So this is our attempt to do that. Let's go. So first of all, there's this word rendering. What do we mean by that? Normally, it means melting fat in order to clarify it. That's not quite what we're going to talk about today. Instead, we're talking about the process of actually turning all that stuff like buttons and checkboxes and everything on the screen into pixels that the user can look at. And there's a lot of things going on. There's a lot of details that we are glossing over today because we only have 40 minutes to do this. But we'll dump a lot of details on you along the way. So first of all, I'm going to take you through, there's going to be a bunch of colored dots on the top, and these will be sort of a visual cue for a lot of the rest of the talk. So I'm going to walk through sort of the life of what happens in the flow of information down to the pixels on the screen really quickly. We have this thing called the choreographer, and that kicks in usually 60 times a second, and it says, hey, vsync. This is the interval at which the frame is being synced. Buffers flip onto the screen. It's a good time for us to process a lot of information and then handle rendering that information as a result of that. So we get a vsync operation that's sent up to the Java SDK lands, and we're on the UI thread, and all of a sudden we need to process input events, which can trigger changes in properties. We also run any animations, so we change property values. Again, that may trigger things like layouts and invalidation. We do then the whole traversal pass, which is measuring views to figure out how large they are, laying them out, which is actually positioning them to where they need to be, and then drawing them. Once all of that information is done, we sync the result of that information over to this thing called the render thread. And the render thread takes that and says, okay, well, I'm going to then execute these. I'm going to basically turn these into native versions of all that information we produce at the Java layer. And then I'm going to get a buffer from the GPU so that I have a place to write this information. And then I'm going to actually issue all these GPU commands, this OpenGL stuff over there. And then I'm going to say, OK, it's time to swap the buffer. And then I turn it over to the GPU. And then the graphics system does something called compositing. And we're going to talk about most of these steps today.
So compositing is, I think, something we've never explained before. So we're going to go in a little bit of details about this part of the Android rendering architecture.
So the little colored dots on the top of the screen will be sort of noting where we are in the process as we work through a few examples so that we can understand this better. Speaking of examples, here's a simple one. So let's suppose that we have a user and the user clicks on an item. I wrote this awesome Recycler View application that looks exactly like this. I know it is because that's a screenshot from my awesome application. It's a Recycler View with a bunch of items in it, and when the user clicks on one, this amazing thing happens. It turns into a random color in the background. It's incredible. I could give you the source, but I don't know. It's pretty complicated. I'm not sure you'd understand it. So here's the amazing layout for my amazing demo application. There's a constraint layout. There's a Recycler View inside of it. And then I populated it at runtime with a bunch of random items in there. All right, the view hierarchy for this thing looks basically like this. In fact, it doesn't look basically like this. It looks exactly like this. So you walk down from the decor view, and you've got a linear layout and frame layout. And I'm not exactly sure why we have the deep nesting there, but whatever, history. We have a bunch of stuff for action bar in there. None of that really matters. What we're concerned about here is what's actually going on in the content hierarchy, because that's what you can affect with your application. So we have content frame layout. We have the constraint layout on the outside, wrapping the Recycler View, and then all of the items. And specifically, these are the items that are on screen, because those are the only ones that are actually being measured and laid out and drawn. All right, so what happens? Let's walk through this example and walk through that entire flow that we went through at the beginning. So user clicks, there's a vsync operation. That gets sent up, and we process input during the input phase. And we notice that this is a click. I'm glossing over some details here. Actually, we're going to notice first that there was a down, and then there was an up, and then it gets processed as a click. Just take it for granted. We're eventually going to process a click here. All right, that ends up in this item clicked method that I have in my amazingly complex example. And in there, we're going to set the background color on this item to a random color. That's why I call the method random. All right, that gets sent over to the set background color in view.java, which does a bunch of stuff to set the color on the background drawable, and then eventually calls this method called invalidate. Invalidation is the process, it doesn't actually redraw the views, it's the process of telling the view hierarchy that something needs to be redrawn. So, we get a click, that happens on the item down at the bottom, so that item 2, you see it's surrounded by green. We have a little invalidate method that gets called on that, and that basically walks up the tree. It calls a series of methods all the way up the tree because the view knows that it needs to be redrawn, but it actually needs to propagate that information all the way up the hierarchy so that then we can redraw all the things on the way down later. So we call invalidate child all the way up the hierarchy. That eventually ends up in a massive class that we have called viewRootImpl.java, and we have this invalidate child method there, and that basically does nothing except says, okay, I need to schedule a traversal, which means, okay, I've taken information that somebody got invalidated somewhere. That means that I need to run my traversal code later at the end of this process. Traversal is the process of doing all the phases that are necessary for actually rendering that frame. Specifically, it does measure, how big the views are, layout, setting the views, position and size, and drawing the views. All of that is called traversal. So, we've scheduled a traversal. That's going to happen at some later time, and that later time is now. So in the same frame, we end up in the traversal code in this perform traversals method. It's going to do a perform draw, which ends up calling a draw method onto core view, and basically that's going to propagate all the way down. So the draw method actually ends up in an optimization that we implemented back in Honeycomb called getDisplayList. So a display list is a structure that stores the rendering information, right? So if you look at the way the button code is written or view code in general, we call graphics commands in Canvas like, I don't know, draw backgrounds, draw drawable, draw line, whatever. But these end up as operations in a display list. This is a compact way of representing those operations as well as the parameters to the operations. So we call getDisplayList. The decor view did not change, in fact. So it's going to say, well, I didn't change, but I can certainly get the display list for my child, and then on all the way down the tree until it gets to item 2, and it says, oh, I did change. Like when invalidate was called on me, that triggered something so that I know I need to redraw myself. So getDisplayList actually ends up being a draw call on the view where it regenerates its own display list. So now it ends up in this onDraw method. That ends up in the operations in the display list for that. The display list consists of, for this item, basically rect information and text information, pretty basic. And then we have the display list for basically the entire hierarchy, right? So it wasn't just the view itself, but we have the view hierarchy itself is reproduced in this hierarchy of display lists all the way down. So now we have the display list for the entire tree, and that's all that we need to do on the UI thread. Now we need to sync that information over to the render thread, and the render thread is a separate thread that's actually dealing with the GPU side of this operation. On the Java side, we produced all the information. On the native side, then we actually produce, we take that information and then sync it over to the GPU. So we have the sync operation where basically we copy a handle over there, and we also copy some related information. We copy the damage area because it's important to know that that item 2, that's the only thing that changed during that frame, which means we don't need to redraw anything else outside of that area. So we're going to copy over the clip bounds there so that we know what needs to be redrawn. And we're also going to do some optimization stuff like uploading bitmaps. So this is a good time to do it at the beginning of the frame, give them some time to actually turn those into textures along the way while we're doing the other stuff.
It mentions here that we're uploading the non-hardware bitmaps. So hardware bitmaps is a new type of bitmap configuration that was added in Android O. So typically when you have a bitmap, we have to allocate the memory on the Java side, and then when it comes time to draw, we have to make a copy of the bitmap on the GPU. This is expensive, it takes time, and it doubles the amount of RAM we're using. So using the hardware bitmaps that are available in Oreo, you can skip the Java side of the equation, and you can have a bitmap that lives only on the GPU. So if you're not going to modify this bitmap ever again, this is a really efficient way, memory-wise, to store your bitmaps in memory.
We have mentioned the render thread before. This is something that we introduced in the Lollipop release. It is a separate thread that only talks to the GPU. It's native code. There's no callouts out to Java code. There's certainly no callouts out to application code. It just talks to the GPU. We did this, so we still need to do basically the same thing we did pre-render thread, which is we produce all the display list information, and then we sync, or we send that display list information to the GPU, so it's sort of serial, but the render thread is able to do things atomically, like the circular reveal animations, as well as the ripple animations, as well as vector drawable animations, can happen atomically on the render thread. So that's something that can happen without stalling the UI thread. And in the meantime, the UI thread can be doing other things while it's idle after it's synced, like maybe some of the idle prefetch work for Recycler View that was done last year. So render thread kicks in. We've synced everything. We have the display list. We have the damage area. And then we turn the display list into something that we call DL ops, display list operations. So you can see that we have that fill operation in the middle. That's the thing that we turn green there. And then we have some optimizations that we perform.
So we have various optimizations we do here. So for instance, if you do alpha rendering by calling set alpha on a view, or if you set a hardware layer on a view, we try to identify the drawing commands that need to be targeted to those layers, and we move them at the beginning of the frame. This avoids do state changes inside the GPU, which are extremely expensive. So without doing this kind of optimization, you would see like horrible performance. And it's not that because the GPU itself would be slow, the GPU would just be waiting for the CPU to give it instructions. The other one we're doing, and we're going to show you an actual practical example, it's called reordering and batching. We look at all those operations, and you can see in this example, because we have list items, we interleave a lot of operations that are similar. So we're going to draw a rectangle, then we're going to go draw text, and we're going to draw a rectangle and text again. And again, here we're changing the state of the GPU several times. But instead, what we can do is, if the commands don't overlap, we can draw all the rectangles together, and then we can draw all the text together. So this is part of the reordering and batching. And sometimes what we do, we say, look, if we see a bunch of text that use the same color and the same font, they don't have to be different draw text calls. They can be just a single one that covers the entire screen.
So you can see here the original DL ops had a fill operation, and then it wanted to draw some text, which is going to end up being texture map copies from the glyph cache. Then it's got a fill operation, and then some more text and a fill, and so we've got all these operations interleaved. So after the reordering operation, then it looks a little more like this. We've got a series of fills and a series of text operations. They can even be batched together to be more optimal, which we will see here.
So this is an example of Gmail. So that was in the honeycomb era. You can see how here we modified the pipeline to slow down the rendering, and you can see exactly how Gmail was drawing. So we have a lot of list items, and we just draw them in the exact order they are. They exist in your view hierarchy and in the order of your code, actually. Like all the draw calls that you make on the canvas will respect that order. Unfortunately, like I said, it's very inefficient. So instead, after batching and merging and reordering, we get this. You can see in particular that all the stars were drawn at the same time, and most of the text appear all at once. What's interesting is we are drawing all the list item backgrounds one after the other, so that's good. The reordering worked. The batching didn't work, and it's probably because the list items are slightly overlapping. So when commands overlap, we have to draw them one after the other to honor the blending, to make sure the alpha values are correct. And so the effect really depends on the application. If I remember correctly, in KitKat, the settings application was we could draw the whole screen in about 6 draw calls instead of dozens and dozens as seen by the view hierarchy. So this is a very important optimization for us.
I think this work at the time on current devices saved something like a millisecond, which doesn't sound like much unless you realize that we have to do everything within 16. So it was actually a huge improvement that allowed Gmail to be less janky, because then it wasn't pushed out into the next frame as often. All right, so back to our explanation of everything. Then we have the clip reject. So this is where we feed in the information about the damage area, right? So we know where item 2 was on the screen, and we know that we don't need to draw anything outside of that. So as we're processing these DL ops, we know that we can basically throw away anything that is drawing outside of that area. In graphics, that's called a trivial reject. So we trivially reject all the DL ops that weren't intersecting with that area, and now all we have to do is draw a fill and some text and a line. So we do that. In the process of doing that, we do a get buffer. This is usually an implicit operation. We don't request a buffer. It's more that as soon as we start doing GPU operations, then the GPU hands us the buffer, more particularly Surface Flinger hands us the buffer that we can then put these commands into. Then we issue the commands. This is a series of GL commands. As you can see on the slide, it says GL commands, basically the equivalent of what we need for whatever, doing the fill or the text, bitmap copies, lines, whatever. And then we swap the buffers. So this is us saying, we are done with all of our rendering operations. We're ready to display this frame on the screen. It's a request to Surface Flinger to then swap the buffer. Basically, we're done drawing to the buffer. You can swap this with the one that's in front, and it'll put it on the screen. Meanwhile, in Surface Flinger, then we have the composite step, which Romain is going to talk a lot about later, but basically it takes all of the windows on the screen. We see here the navigation bar, the status bar, and the actual content window for our application. It combines all of those in the hardware compositor, puts them on screen, and then ta-da, we're done. All right, so that was a really simple example. Let's look at a super complicated example. This one's going to be in two phases. One, so we're going to drag the list up. So we're going to drag it, and then as we drag it, we're going to move the items a little bit, and then eventually, if we keep moving them, we're going to have a new item appeared. So we're going to look at two versions of this. There's the move-only version. So as we drag it up, a new item, not a new item appears. Everything just shifts a little bit up. So first of all, we need to process the down. So we have a vsync. It says time to process input events. So we do that, and we end up in code like this. On touch event in recycler view, it says, well, there was a down operation, and all it needs to do is register where that down happened. It doesn't need to process anything. Nothing changed on the screen. We just register that the user actually pressed down. So we record that for later, and there's no op. We don't do any of the rest of the stuff we talked about because nothing changed. All right, they keep dragging, and then we end up in similar code. So we process input on the next frame, and we say, OK, on touch event, oh, now we know that they've actually moved. When we know how much they moved because we saved the old x and y, and we calculate the delta. And now we call this thing called offset top and bottom. We basically, for all the views on the screen, we simply move them in Y. And offset top and bottom calls something, it's an invalidation method, but it's slightly different. It says invalidate view property. This is an optimization that we put in probably Honeycomb second release or something with display list properties. So when I talked about display list earlier, there was one nuance that I left out. We have the information about the operations and the parameters for the graphics operations, but we also have information about some core display list properties, which are basically properties of the view, like the translation property, rotation, alpha, and these are properties which we don't need to re-render the view to change. We can simply change them in the display list structure itself, and then they get picked up at GPU issue time. So it's a very fast operation for us to do that. So instead of invalidating a view and redrawing everything in that view, all we do is say, change the translation property in this view. So the way that happens is we call invalidate view property. That propagates all the way up the tree because we still need to know at the top layer what happens, but it's a much more optimal step. So this ends up in scheduled traversals as it did before. In the draw, it ends up in perform traversals, but perform draw can do a much simpler version of this because the display list didn't actually change. All we did was change display list properties inside of it. So we can immediately sync that information over to the render thread. We can then execute that, turn that into display list ops, get the buffer. Basically, everything is as before. All right, let's go through the second phase of that super complicated example. User keeps dragging, and as they drag, a new item appears on the bottom. So vsync, we process the input. We end up in a method something like this. OK, we know that they've moved. Oh, but that means that we need to trigger the creation and the bind of that new item there. That ends up in code like this, where we actually add a view to the parent. So the recycler view is going to get a new view, and it's going to call request layout. So request layout is kind of like invalidation, but instead of saying, I need to be redrawn, it says, I need to be remeasured and relayed out. And that could side effect everybody there, so we basically propagate a request layout all the way up the tree, like invalidation, and then we do measure and layout on the entire tree just to see what changed there. So request layout happens on the parent, and then that propagates all the way up. And that ends up, again, in scheduled traversals, our friend. And then perform traversals, we're not talking about the draw stuff now. We're going to do a perform measure and a perform layout. Measure is basically asking all of the views how big they would like to be. It's a request. And then layout says, this is how big you're going to be, and this is where you're going to be positioned. It's a negotiation between the views and all of their parents according to all the constraints in the system. So we do a perform measure that basically calls measure at the top, and that propagates all the way down. And then we have all the information about how big all the views want to be, and that is good enough for us to calculate the layout information. Then we propagate layout all the way down the tree. And once that happens on the item and the parent that changed, then we actually lay out that item and we're ready to go. Now we can actually draw things and everything is as before. So the nuance here was just the layout side. Except an important nuance is we're talking about all of this request layout and measure and layout happening for this recycler view situation. However, recycler view optimizes this. It knows enough about its own parent and its children that it actually can just offset the views. Instead of doing the request layout, it can actually just move the views out of the way and create the new item. So optimization for recycler view as well as the older list view.
All right, so now we're going to talk about how Surface Flinger, our window compositor, composites all the windows on the screen. This is interesting, well, first of all, because it's always interesting to learn something new about technology, but also because you will understand some concepts that are behind some of the public APIs like Surface, Surface Texture, Surface View, or in the media codec. So before we can understand composition, we have to understand a very important concept on Android called the buffer queue. So the buffer queue, as the name suggests, is just a queue of buffers where our graphics buffers live. Typically, we're going to have 1, 2, 3 buffers. There are different options internally where when we set up a buffer queue, we can request how many buffers we want. And very importantly, a buffer queue has 2 endpoints. We have the producer and we have the consumer. So typically, the way we use a buffer queue, the producer calls a method called dequeueBuffer on the queue. It grabs a buffer from the queue, now it owns it. It can do any kind of rendering. It can be sending the pixel data directly. It can be using OpenGL. It can be using the canvas. It doesn't really matter. And when you use OpenGL, this is basically what happens when you call swap buffers at the end. That's when we're producing the content inside the buffer. So when the producer is done producing the content, it calls queueBuffer and gives the buffer back to the buffer queue. Now our consumer can grab the next buffer in the queue using acquire. So it calls acquire buffer, it takes the first available buffer in the queue, it does whatever it has to do with it, and when it's done, it puts it back by calling release. So it's a pretty simple concept. Of course, if you were to look at the code, all the header files and all the nav code involved, it's pretty complicated, in part because the 2 endpoints of a buffer queue can live in different processes. And this is exactly what happens. This is how our Surface Compositor works. So when you create a window in the system, you have the window manager, and you have Surface Flinger. So the window manager is effectively the producer in this scenario, and Surface Flinger is our consumer. So when you call window manager.addView, and this is what's done automatically for you when you create a dialog, when you create a toast, I believe, when you create an activity, internally we create a window object, and that window object has a sibling on the Surface Flinger side called a layer. The names can be a little confusing because in graphics we have to deal with buffers and queues, and that's all we do. And we quickly run out of names. And the graphics team, I thought of, so that's why we have surface and surface textures and buffer queue and layer and window. And yeah, so it's a little bit messy. So we have a layer in Surface Flinger. It's basically a window. And the layer is the component in the system that creates and owns the buffer queue for your application. So it creates a buffer queue, and we have a way to send the endpoint to your application by creating a surface. So whenever you see a surface in one of our APIs, you really have the producer endpoint of a buffer queue that lives somewhere else in the system, either in your process or in some other process. Most of the time, it's going to be inside Surface Flinger. So now, when the typical use case for you as an application developer, you're going to deal with the Surface API when you create a Surface View. So the way Surface View works is your window has its own surface that we see here. Then we cut a hole through that surface effectively. And we ask the window manager and Surface Flinger to create a second surface, and we just slide it underneath, and we pretend that they're part of the same window, but they're not. They're two different surfaces, they have 2 different buffer queues, and they can be completely independent from one another. So if you use a Surface View, you're probably going to use OpenGL or Vulkan or a media player to generate content. So for instance, in this case, we have OpenGL, yes. It's going to dequeue a buffer, it's going to do some rendering, and it's going to queue the buffer back into the surface, and therefore into the buffer queue. if you use a surface texture, so your consumer will be OpenGL. So you create a surface texture by giving it a texture ID. In that case, the surface texture creates and owns the buffer queue. So that will often be in your own process. Then you have to pass that surface texture to some producer. And to do this, you create the endpoint yourself by creating a surface. There's a constructor of surface that takes a surface texture. So you create your surface, you send it to some other application, and then when your OpenGL code is ready to render, it calls acquire to get a buffer from the buffer queue. It does its rendering. It's going to itself produce a buffer inside another queue, and then when it's done, it can call release. Texture view is the widget that's part of a UI toolkit that you can use to benefit from surface texture. In that particular case, the render thread that we talked about is the consumer of the surface texture. And you're still responsible for getting the surface from the texture view and giving it to a producer of your choosing. You can think of it as a fancy image view, effectively. It's an image view that you can update really efficiently using hardware acceleration. In recent years, we used to tell you that texture view was the solution instead of surface view when you wanted to integrate a video or OpenGL rendering inside a complex application. For instance, if you had a list view or a card view or anything that was animated, surface view, because it's made of two different windows, was not really efficient for that, and it was not synchronized with the rendering of your own application. This has been fixed in recent versions of Android. So most of the time on recent versions of Android, you should use a surface view instead of a texture view. Use a texture view only when you have to. Maybe it's sandwiched between other views, or use an animation that's not supported by the surface view.
I think that was the O release.
There was O, maybe an N.
Maybe.
One of the two. You have to test.
That's why we say recent.
So, and here's a list of different producers and consumers in the platform. So we looked at surface view and surface texture. OpenGL, yes, is a producer. It can also be a consumer. So remember when Chet was saying that in that life cycle of a frame, at some point we get a buffer. That's when we call DQ buffer from the render thread. And this is done typically when we do the first draw call. And at the end, when we call EGL swap buffer to tell the driver that we're done with our frame, it will actually produce the frame and put it back in the buffer queue. You can also use things like Vulkan, the media player, and media codec. And we have many, many more throughout the platform. Now, the actual composition. So we have created multiple windows. They each have their own layer. Surface Flinger knows about all those layers. And to talk to the display, Surface Flinger actually talks to something called a hardware compositor. The hardware composer. Hardware composer is a hardware abstraction layer that we use because we want to avoid using the GPU and we need to composite all those windows on screen. One of the reasons is to save battery. It's more power efficient that way. But it's also to make sure that your application has access to basically all the capabilities of the GPU. We don't take it away from you. And in the past, you may have heard that you should limit the number of windows you put on screen, and you'll see why in a few slides. So we have the hardware composer. It's effectively a block of hardware that's really fast at taking multiple bitmaps and compositing them together on screen. We just talked about this. So the way it actually works, the hardware composer is really a kind of a protocol. Here I'm going to describe the older hardware composer. It's called hardware composer 1 or hardware composer 0. I'm always confused. Now we use one called the hardware composer 2, but it's much more complicated, so I'm not going to describe it here. But the gist of it is it basically works the same way. So Surface Flinger has a bunch of layers. And we're going to call prepare on the hardware composer. And we're going to send all the layers to the hardware composer and ask it to tell us what it wants to do with every layer. Every hardware composer is a proprietary piece of hardware in the phone or tablet you're using, and there is no way that we can write the drivers for all the different hardware composers out there. So instead, the hardware composer is going to tell us what it wants to do. So in this case, we have a layer. The hardware composer replies overlay. That means the hardware composer understands the pixel format of that window and tells us that it can handle it, and it's going to do the composition for that window. So we keep going. It's telling us overlay for the second layer. It's telling us overlay for the third layer. So that's great. That means all the composition can be done automatically for us on our behalf in a very efficient way. So now all our layers are matched to overlays. We call set. We send all the layers to the hardware composer, this time for actual composition. And the hardware composer sends everything to the screen. Now a more complex example. So we have a number of layers we call prepare. For the first one, everything goes fine. The hardware composer says overlay, it can handle it. But for some reason, for the next one, it says frame buffer. So that can happen when you're using a pixel format that's not supported, or it could be because you're using a rotation and the hardware composer doesn't know how to handle rotation, or we have too many layers on screen, or any number of reasons that are specific to that hardware composer.
This was much more common in devices probably 3 to 4 or longer years ago.
We used to have about 4 hardware layers that you could use. That's 4, that's 5, that's 4. So we used to have 4. And on Pixel 2, without going into too much detail, you have basically 7. So it's much better than it used to be. But if you have a Pixel 2 XL, we use 2 of those layers to draw the rounded corners. So you don't really have 7, you have 5. It's actually more 6 because they can be merged by the hardware composer. Anyway, lots of details. It can be really complicated. You don't need to know about all those details. Anyway, in this case, we have 1 layer that can go directly to the hardware composer, but we have 2 layers that have been marked frame buffer. So, and that's where the hard part starts for us, because when we have layers that are not handled by the hardware composer, we need to use the GPU to composite them ourselves. So Surface Flinger has to be able to do everything that the hardware can do. And in that situation, we need to create basically a scratch buffer, another layer, in a format that we know the hardware composer can accept. And then we use custom OpenGL code to do the composition ourselves of those 2 layers. So then, once we're done with that part, we're left with only 2 layers, and we know that those can be sent to the hardware composer. So that's what we do. We call set, and then they show up on screen.
So if you're curious sometime, you can run this command, ADB shell dump sys surface flinger. And
capital S, capital F.
Okay, very important. And it'll spit out way, way, way more information than you want. But one of the things that it's going to show you is a table of the windows on the screen and whether they are currently represented as overlays or frame buffer.
Although you have to run this command pretty quickly because there are tons of optimizations internally. So what can happen sometimes is if layers have been on screen for a while and we know they're not changing, the hardware composer might be collapsing them into a single layer until they change again. So the output of that command is sometimes a little bit misleading because you might be seeing the result of optimizations based on time. So the best thing to do is usually to run this when you're running an animation or something is changing on screen. That's going to be the most valuable information for you. So a few other things that we haven't talked about. We used to tell you to use the variant of invalidate that takes a rectangle. So you could invalidate only part of your view that you knew needed to be repainted. That was particularly important with older Android devices because bandwidth was extremely limited. We were using software rendering. And even in the early days of GPU rendering for us, we were pretty easily maxing out the GPU. So those were really important savings. You don't need to do this anymore. And even on recent versions of Android, before this was deprecated, it was actually ignored by the system. Now what happens is every time you go invalidate or invalidate with a rectangle on a view, the render thread is going to re-render that whole view or recompute its whole damage area. You don't have to worry about it. And one of the reasons we're getting rid of it is not only is it not that necessary anymore for savings, but it's also because it's error prone. And it's really easy to have an off by 1 error or rounding error and to get artifacts on screen. And Chet and I can attest to that because we fixed so many bugs linked to the use of those APIs. And the framework itself still has bugs, I believe, around that. So now you don't have to worry about it. RecycleView is now able to do prefetching of item ahead of time.
Yeah, we mentioned this earlier. This is one of the wins that we're now getting out of having this separate render thread because now, well, there's idle time. The UI thread was done with its work after it's synced. Well, it can use that idle time productively for doing other things like fetching things that it know it might need in the next few frames.
For composition, internally, we have a concept of virtual display. There's an API you can use. For instance, that's what we use when we take a screenshot or when we record a video or when we do casting, Chromecasting, for instance. What we're effectively doing is asking Surface Flinger to perform a composition, but not to the display directly, just into another surface. So it's another way of producing a surface. If you're interested, there's an excellent sample application called Graphica with a K available on GitHub. It was written by a member of the graphics team a few years ago. And it's basically a collection of all the things you can do with Surface Flinger, with surfaces, with Surface View, with the media encoder, with virtual displays. It's a very interesting piece of code to look at. Color transforms, so in Android O, we introduced color management, and that's one of the color transforms we can apply. Things like night light are also color transforms. We also have color blindness simulation. Those can be handled by the hardware composer in specific situations. And they can be the cause for performance issues. For instance, a while back, Nightlight was not supported, I believe, on the N5X or the N6P. One of the reasons was the hardware. We didn't have the drivers that could do the color transform, so we had to fall back to GPU composition. It was really expensive, it was hurting the battery, so we didn't have the feature on the device. And like Chet said, there are many, many more details about our rendering pipeline. This was just a very high-level overview. We gave a number of talks in the past that explain in more details what we do, for instance, in the UI renderer itself, how we do the batching and merging, that kind of optimization. So if you're interested, you can refer to
Shadow calculation is interesting. I think we had a talk where we talked about some of those details, but exactly where does that fit in the rendering pipeline is sort of clever. But yes, lots more going on there, but hopefully this gives you a general sense of how things work on Android.
And with that, we're done. We may have time for one question.
Sure.
So if you have a question, you can walk up to one of the mics. And after that, we'll have to run away from here to go to our next session.
Yes.
Back in the demo, click the button again, and DevTools pauses on the first line of this onClick function. The blue highlight indicates what line of code you're currently paused on. If you're paused on a different line of code, press Resume Script Execution until you're paused on the correct line. You paused on the wrong line because you have a Chrome extension which registers click event listeners on every page that you visit. If you try the workflow I'm describing in an incognito window, you can see that you always pause on the correct line of code. Event listener breakpoints are just one type of breakpoint. DevTools offers many other types. For example, you can set a breakpoint on a specific line of code, or when a DOM node changes, or when an exception gets thrown, and so on. After this tutorial, I recommend checking out our breakpoints guide, which teaches you when and how to use each type. The link to that guide is in the description too. I'm paused in the click listener, and now I want to execute the code one line at a time. The code stepping controls right here let you do that. Click the Step into Next Function Call button to investigate a function further. For example, when I step into the Inputs Are Empty function, it jumps me to the first line of that function. When I'm confident that a function is working as expected, I can click the Step Over Next Function Call button. The function executes, but I don't walk through it line by line. For example, if I clicked Step into Next Function Call, this line here would be highlighted blue, meaning this is where I'm currently paused. But when I click Step Over Next Function Call, the function executes to completion, and I pause on the next line of the function that I'm currently stepping through. Last, suppose I'm stepping through a function and I realize it's not relevant to my bug. In that case, I can press Step Out of Current Function, and DevTools executes the rest of the function. If this doesn't make complete sense right now, I recommend creating a snippet, which is a little block of JavaScript code that you can execute at any time. Set a breakpoint in your snippet and play around with the code stepping controls yourself in order to understand how they all work. Back in the script, I can tell that the bug is probably somewhere in the update label function. Rather than stepping through a bunch of irrelevant code, I can set a line of code breakpoint right around where the bug probably occurs. To do that, I just click the line number next to the code. This blue icon indicates that there's a breakpoint on this line. When I press Resume Script Execution, DevTools runs all the code up until that line, and then pauses before that line executes. Over here in the JavaScript debugging pane, I can see the call stack that caused this code to execute. I can click on the functions to see where each one got called. The scope section shows me all of the local and global variables that are currently defined at this moment in time. I can click on values to edit them, but I'm not going to do that right now. However, when I look at these values, they look suspicious. They're wrapped in double quotes, which means that they're strings. This could be the cause of the bug. I'm going to investigate this further over in the Watch Expressions section. Here I can watch the values of variables over time. You can store any valid JavaScript expression here. For example, I click Add Expression, then type of sum, then press Enter, and I can now see the value of that expression. As I suspected, sum is a string when it should be an integer. Now I'm going to open up the console to test out a potential fix for the bug. When I'm paused on a line of code, the console has access to all the variables that are currently in scope. For example, when I evaluate addend1, it returns 5. I think I can fix this bug by converting the addend1 and addend2 variables to integers before adding them. So let me try that now. Yep, that fixes it. I can verify that this change fixes the bug by editing the code directly from DevTools. First, I'll resume script execution, then make my change. To save the change, I press Command-S on Mac or Control-S on Windows and Linux. Then I click Deactivate Breakpoints so that I can test out the app without triggering the breakpoints I've set. Now the app sums up numbers as expected. All right, you now have an excellent foundation in how to effectively debug JavaScript using DevTools. From here, I recommend learning about all of the breakpoints that DevTools has to offer, as I mentioned before. We also have a JavaScript debugging reference where you can learn about literally every feature related to debugging in DevTools. Links to both are in the description. Thanks for watching and happy bug hunting.
Hello from IO Live. I'm Florina Montanescu, and I'm here with Ankit, the product manager at Google Pay. Hi, Ankit.
Hi. Thank you for having me.
So, what's Google Pay?
So Google Pay is our payment solution for both online and in-store. We enable Google has hundreds of millions of credit cards on file, from Chrome when users autofill in Chrome through Google Pay, when users pay on the Google Store, YouTube, Play. We're bringing the power of all of those cards that we have to stores, both in physical stores and in online stores.
Okay, so how about merchants that have an omni-channel?
Yeah, so we enable a variety of experiences. So online, for example, we allow you to have a Google Pay button that enables a one-click checkout with any of these credit cards on file. In store, we allow you to accept payments through NFC. We have a set of loyalty solutions so we can help you enroll users in your loyalty program, make sure loyalty is conveyed at the point of checkout. And then today we're also announcing, like a good mobile wallet, we're supporting other items that users have in their wallet. So boarding passes, event tickets, offers, that sort of thing. If you are an omni-channel merchant, we're happy to work with you. We enable it. One of the demos that we have today showcases this very well. We have an experience that we've built with Oak Labs and Dot-Dash Pay. It's a smart mirror. You walk into the dressing room with your items, the mirrors will detect it. We then enable a one-tap checkout with your phone. Your loyalty is conveyed, as is your payment credentials. And then after that, you're rewarded with an online offer that you can then use on their online stores. And so this is an example of how we can bring users back to the merchant after having an in-store experience.
Okay, sounds great. I'm a developer, so how do I get started with it?
Yeah, we provide a suite of APIs. It's with just a few lines of code. We enable you to add a buy with Google Pay button, or a Google Pay button for your website. We also have APIs that allow you to accept loyalty or allow you to help get users enrolled in your loyalty program, and you can learn about those at pay.google.com.
Okay, so check out pay.google.com and get started with Google Pay. Thank you, Ankit.
Thank you.
I'm Florina from IO Live.
Hey everyone, we're now at the Web Sandbox, and we're going to talk to Paul about Lighthouse. Now, you may remember Lighthouse gives you actionable advice for improving your websites. Paul, come on over here and show us what this is all about.
How you doing? Yeah, so this is our Lighthouse, real-world Lighthouse that we've got as well. So Lighthouse is our tool that helps developers actually fix the problems on their sites. So we open up Chrome, run DevTools, and then we just inspect a whole bunch of the tools that we've got, or the problems on the page, and give developers actionable advice. But the problem that we've got is that we've got a lot of different tools. So this is our actual central place to try and unify Google's performance, informational, architectural tooling story as well. So should we give it a demo?
Yeah, let's do that.
All right, cool. So here we go. I'll use my site because it's probably the best, and I like people to go to my site. So what happens? We're going to enter the URL. And so basically developers at the event are going to be able to come up, put their URL in, and then get actual real-world feedback about how to improve their site. So we press go, and it goes off. It runs Lighthouse, it runs PageSpeed, and also Web Page Test. And we've also got a number of other different tools as well, which we're not kind of automating today because it's a little bit too much. But we want to give developers an idea of what's happening. So the first one's already come through, the PageSpeed Insight score. So the general mobileness is good. I'm 99 out of 100. And then the Lighthouse scores have also come through as well. So I'm doing well in performance, progressive web appness. I'm not doing very well in accessibility. I need to fix that. And my SEO is pretty poor as well. And then if you want a little bit more detail, we've got the view report button as well, which will give you a full detailed report that you can go and send back to your manager and tell them, like, you know, everyone's just seen how poor our site is. Let's go and fix it. Or how good it is, actually. And give me a raise. So yeah, that's our Lighthouse, our PageSpeed. We've got a numerous range of different tools, and like this whole area is about trying to show you kind of what goes where and how to use it and when.
This is awesome, Paul. And I have to admit, I was kind of expecting the hundreds across the board.
Yeah, I know Dion said the same as well, and he's going to have words with me later on. So.
Thank you so much for showing this.
Thank you very much.
All right, if you want to see more videos just like this, remember to head on over to g.co/io/guide. I'm Timothy Jordan. I'll see you in the next one.
If you're still using console.log to find and fix JavaScript issues, you might be spending more time debugging than you need to. This tutorial shows you how to make the most of Chrome DevTools so that you can debug your JavaScript as quickly as possible. I'm going to use this buggy demo here to demonstrate all of the debugging tools in DevTools. I recommend that you open up this demo yourself and follow along with each step. The link is in the description. Whatever issue you're debugging, you always want to start by reproducing the issue. You want to find a series of actions that consistently reproduces the bug. In this demo, when I add 5 and 1, the result down here at the bottom is 51. Obviously, that should be 6. This is the bug that I need to track down. At this point, you might be tempted to use console.log to infer where the code is going wrong. Sure, it may get the job done, but it's rather inefficient. First, you have to find the relevant code, which could take a while in a big code base. Then you have to sprinkle console.log statements throughout the code. Then you got to reload the page and look at the logs. But maybe the logs didn't give you all the information you need, so you got to go back and add more logs, and so on. With DevTools, you can pause the code in the middle of its execution, inspect the variables that are in scope at that moment in time, and walk through your code one line at a time. Open DevTools by pressing Command-Option-J on Mac or Control-Shift-J on Windows and Linux. Then click the Sources tab. The Sources panel is where you debug JavaScript. It has 3 main parts. At the top left here is the File Navigator pane, where you can inspect the files that the page uses. After clicking on a file, you can see the contents of it here in the Code Editor pane. And down here is the JavaScript debugging pane, which you'll learn more about shortly. Note that when your DevTools window is wide, the JavaScript debugging pane moves to the right. If you take a step back and think about how the app works, it's probably safe to guess that the incorrect sum gets computed in the click event listener that's associated to the button. Therefore, you want to pause the code right when the event listener executes. Event listener breakpoints let you do exactly that. Expand the event listener breakpoints section, then expand the mouse category, then check the click checkbox. DevTools now pauses on the first line of any click event listener that executes. Back in the demo, click button again, and DevTools pauses on the first line of this onClick function. The blue highlight indicates what line of code you're currently paused on. If you're paused on a different line of code, press Resume Script Execution until you're paused on the correct line. You paused on the wrong line because you have a Chrome extension which registers click event listeners on every page that you visit. If you try the workflow I'm describing in an incognito window, you can see that you always pause on the correct line of code. Event listener breakpoints are just one type of breakpoint. DevTools offers many other types. For example, you can set a breakpoint on a specific line of code, or when a DOM node changes, or when an exception gets thrown, and so on. After this tutorial, I recommend checking out our breakpoints guide, which teaches you when and how to use each type. The link to that guide is in the description too. I'm paused in the click listener, and now I want to execute the code one line at a time. The code stepping controls right here let you do that. Click the Step into Next function call button to investigate a function further. For example, when I step into the inputs are empty function, it jumps me to the first line of that function. When I'm confident that a function is working as expected, I can click the Step over Next function call button. The function executes, but I don't walk through it line by line. For example, if I clicked Step into Next function call, this line here would be highlighted blue, meaning this is where I'm currently paused. But when I click Step over Next function call, the function executes to completion, and I pause on the next line of the function that I'm currently stepping through. Last, suppose I'm stepping through a function and I realize it's not relevant to my bug. In that case, I can press Step out of current function and DevTools executes the rest of the function. If this doesn't make complete sense right now, I recommend creating a snippet, which is a little block of JavaScript code that you can execute at any time. Set a breakpoint in your snippet and play around with the code stepping controls yourself in order to understand how they all work. Back in the script, I can tell that the bug is probably somewhere in the update label function. Rather than stepping through a bunch of irrelevant code, I can set a line of code breakpoint right around where the bug probably occurs. To do that, I just click the line number next to the code. This blue icon indicates that there's a breakpoint on this line. When I press Resume Script Execution, DevTools runs all the code up until that line, and then pauses before that line executes. Over here in the JavaScript debugging pane, I can see the call stack that caused this code to execute. I can click on the functions to see where each one got called. The scope section shows me all of the local and global variables that are currently defined at this moment in time. I can click on values to edit them, but I'm not going to do that right now. However, when I look at these values, they look suspicious. They're wrapped in double quotes, which means that they're strings. This could be the cause of the bug. I'm going to investigate this further over in the watch expressions section. Here I can watch the values of variables over time. You can store any valid JavaScript expression here. For example, I click add expression, then type of sum, then press enter, and I can now see the value of that expression. As I suspected, sum is a string when it should be an integer. Now I'm going to open up the console to test out a potential fix for the bug. When I'm paused on a line of code, the console has access to all the variables that are currently in scope. For example, when I evaluate addend1, it returns 5. I think I can fix this bug by converting the addend1 and addend2 variables to integers before adding them. So let me try that now. Yep, that fixes it. I can verify that this change fixes the bug by editing the code directly from DevTools. First, I'll resume script execution, then make my change. To save the change, I press Command-S on Mac or Control-S on Windows and Linux. Then I click Deactivate Breakpoints so that I can test out the app without triggering the breakpoints I've set. Now the app sums up numbers as expected. All right, you now have an excellent foundation in how to effectively debug JavaScript using DevTools. From here, I recommend learning about all of the breakpoints that DevTools has to offer, as I mentioned before. We also have a JavaScript debugging reference where you can learn about literally every feature related to debugging in DevTools. Links to both are in the description. Thanks for watching and happy bug hunting.
Build you up when you think you're alone, and no one picks up the phone. Forgotten skin and bones. Oh, yeah, I take you home, fill your body with chrome, build a castle to hold. 'Cause you build me up, oh, 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 and you never let go. Oh, 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 yeah, you build me up, oh, 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 and you never let go.
Hi everyone, I'm Pierre and I'm a software engineer on Google Play.
Hi everyone, I'm Anthony, also a software engineer on Google Play. And I'm Ivo, a partner developer advocate at Google.
So some of you may just be coming from the previous session at the amphitheater, which gave an overview of Google Play Dynamic Delivery and its new publishing format called the Android App Bundle, and how this will make apps smaller. In this session, we will do a technical deep dive on this new publishing format. We will cover what it contains, how to build it, how to publish it, but also the different ways you can test it. We'll also cover how Google Play generates and serves the APKs to end users. So let's start with the format of the Android App Bundle. The Android app bundle is a zip archive. It contains the files you're already familiar with in APKs, such as DEX files, Android resources, assets, native libraries. It's important to realize that the app bundle and the APK are two distinct formats with two different purposes. The app bundle is purely a publishing format, so it cannot be directly installed on a device. It also contains some metadata files that don't end up in the final APKs. They just help the tools build the APKs the right way. Finally, the format of the app bundle is stricter than APK. We want to ensure that the tools can fully understand the files in the bundle so that they can generate valid APKs. Now, let's open up one app bundle and look what's inside. So if you open up an app bundle, this is what you should expect. So this should look familiar to a lot of people. Instead of reinventing the wheel, we decided to reuse some of the structure of APKs and only modify what we needed to better describe the files. So we'll briefly go through them. To start with, the app bundle has support for having multiple modules, as you may have heard before. And we'll tell you more about modules shortly. For now, just know that the top-level directories in the app bundle are the names of the modules. There is always a module named base in the bundle, and that's the one we're looking at here. The Android manifest is still present. In your project, it's a real XML file. In the APKs, you may know it's a binary format. In the app bundle, it's compiled into a protocol buffer format, which allows us to transform it more easily. As opposed to APK, the DEX files are under a directory named DEX. The Android resources, the assets, and the native libraries, on the other hand, follow the same directory structure as in an APK. The only difference are the XML resources, which are also compiled into a protocol buffer format instead of the binary format. The file resources.pb is the resource table. It's the equivalent of the file resources.arsc that you may have seen in your APKs. It describes the resources present in your app and the targeting. The .pb extension meets in a protocol buffer format, which again makes it easier for tools to transform it before it's converted into its binary form in the APK. The assets.pb and native.pb files are the equivalent of the resource table for assets and native libraries. So they only exist if you have assets or native libraries, and they also describe the targeting of the files in their respective directories. As I've mentioned before, the resource table, the asset table, and the native libraries table describe the targeting of the files of your app. So let me explain what I mean by that. File targeting is the description of what type of device or user a given file is targeted for. It's a central concept in Google Play Dynamic Delivery, since understanding the targeting of files means we can serve to a given user only the files they need, and this is what allows us to make apps smaller. The app bundle reuses the targeting that exists in APKs. You're already familiar with this, so I'll run through quickly. For resources, you specify, for example, HDPI in the directory name of your resource to target HDPI devices. Or you add FR to target French users. For native libraries, it's the same. You add the architecture to the directory. Again, nothing new here. The app bundle works the same way. Now, we realize that for some of you, assets represent a big part of your app. So the app bundle also supports assets targeting. We are starting with language targeting, and we will soon be adding texture compression formats and graphics API versions. So we can serve only the relevant assets to the users and reduce further the size of your apps and games. This is how you would create a targeted assets directory. We're making use of the hash sign to identify an asset directory that has targeting. Then comes the key, which defines which dimensions we are targeting, for example, lang for the language, TCF for texture compression format, etc. And then comes the value associated with the key. Well, let's see some examples. Here's an example of a directory containing assets for users speaking French. This is another example of an asset directory targeted based on the texture compression format. Here, we're targeting devices that support the format etc1. Now that you know more about the app bundle format, I'll hand it over to Anthony, who will tell you how we use this to serve smaller apps to users.
Thanks, Pierre. Hi, everyone. So Pierre has just explained to you how we're changing the format of what you publish to the Play Store. And now I'm going to explain to you how we're changing the format of what we serve to users, and how we use this to deliver only what is needed for each user. Now we start with split APKs. So in Android Lollipop, we added a feature to the Android platform called split APKs. Split APKs allow multiple APKs to be installed on a device and behave as if they were part of a single app. These split APKs can be installed in different combinations on different devices, and they can be installed in one go up front or piece by piece. Now, a split APK has the same format as a normal APK. They can contain Java code index files, native code, resources, and assets directories. And once split APKs are installed, these can all be accessed as if they were in a single APK. And furthermore, each split APK shares the same package name and version code with all the other ones that are installed on a device. And they must all be signed with the same key. So now let's take a look at how we can take the Android app bundle and generate split APKs that we then serve to devices. So we start by looking in the app bundle and finding everything that is common to all the devices and putting those in a base APK. So this would include the Android manifest file and the DEX files, for instance. Then we generate a different split APK for each screen density. Each split will contain all the drawables that would have been selected by the Android framework on a device with that density. We can also generate a different split APK for each native architecture, containing native libraries of that architecture. And we can generate a different split for each language supported by your app, putting each language's strings in a different APK. Now, together we call these splits configuration splits, or config splits. Now, when we go to serve an app to a device, we only need to serve a subset of these splits instead of serving everything to every device. So say I have a Samsung Galaxy J5. We will install the base APK, as well as the XHDPI density split, the ARM architecture split, and the English language split, because I only speak English. But it can get a bit trickier than that. Pierre speaks both French and English, and he specifies both of those languages in his device settings. So for his device, a Pixel 2 XL, in addition to the right density and architecture splits, we will serve both the French and the English language split to his device. Now, suppose Pierre then moves to Brazil and learns Portuguese. He might then add Portuguese as a language on his device. Now, when he does this, the Play Store recognizes this and will attempt to download the Portuguese language split for all apps that use splits on the device. And if the device is not online at the time, then we will download those language splits at the next opportunity. And so that's how config splits work. But as I mentioned at the start, splits are only supported on Lollipop and above. This covers about 85% of users at the moment, but most of you still target pre-L devices, which is great. And for these devices, the app bundle still allows us to achieve some of the size savings by generating standalone APKs containing specific densities and architectures. So instead of generating splits as we would do for L+, we would generate this matrix of standalone APKs. We briefly considered extending this to language splits as well, but we did some of the sums and it got a little bit out of hand. So for now, for pre-L devices, we have to include all the languages in each of the standalone APKs. Now, when we go to serve the app, we choose the best single APK for a device. So if we have my first Android device, a Galaxy Nexus, we would serve the HDPI ARM standalone APK. You might recognize this because this is similar to what you may have done in the past with multi-APK. But let's put this all together. The picture looks like this. And you actually don't need to worry about the details about how all these split APKs are generated or standalone APKs are generated. all you have to do is upload a single app bundle, and then Play generates the right splits and selects the right ones to serve for each device. And the dimensions we've discussed so far are only the beginning. Pierre discussed how the app bundle lets you target assets by Graphics API, and we will soon generate config splits based on that. We'll also start generating config splits that take advantage of new platform features, and we'll start with supporting uncompressed native libraries on M+ devices. Now I'll ask Ibo to come up to take a look at how much we can reduce app size by using this app bundle.
Thank you, Anthony. Now that we know how Play serves split APKs to your devices, we're going to talk about the size savings with app bundles. We found out that, on average, apps published with app bundles are 20% smaller. And that is 20% savings every time your application is downloaded or upgraded. Now let's look at how we reached to this number. We analyzed all the applications in Play Store with more than 1 million downloads. And we found out that for strings, we can save over 95% of their size by using the language splits. For images, this is 45%. And for native libraries, we can save 20% of their sizes. This means if every app were to move to app bundles, we would save approximately 10 petabytes of data per day from app downloads and updates. That is 10 million gigabytes or 300 million music videos on YouTube. And on top of that, users could see an extra 300 megabytes of disk space for more photos, more apps, or more music on their devices. So now let's look at actual size savings that some of our early access program partners saw. We're going to start with Twitter. Twitter were already publishing with multi-APKs before, with architecture splits. However, their application is translated into a lot of languages, and it supports multiple screen densities. They still get lots of savings with publishing with app bundles, which is 20% decrease in the size. Plus, they don't have to serve with multi-APKs anymore. The next one is TextPlus, which wasn't using multi-APKs before. With app bundles, they achieved 26% size savings across all dimensions with app bundles. Jomo's app is half of its original size. And this is because they have a large native library and they supported multiple architectures in a single APK. Now let's look at how we can build an app bundle, and you can start saving now. The latest Android Studio 3.2 Canary has full support for building Android app bundles. Now we're going to see a new option to build a bundle in the build menu. Generating a signed app bundle is easy as well. You're going to just select your app bundle, app module, product flavor, and build type, and Android Studio is going to create an app bundle for you, signed, which is ready for publishing. For those who prefer command line or wish to integrate with automated build systems, the new Gradle Android plugin provides a new set of tasks to build Android app bundles. As you remember, this is what you use, the assemble task on the command line to create the APK. Now for app bundles, you're going to switch to the bundle command. Similar to the assemble tasks, bundle tasks also allow you to build a specific flavor of your application. Once the bundle task finishes, it's going to create an app bundle in the output folder with the flavor and the build type chosen. The build artifact is called bundle.iab. Bundle tasks are compatible with the signing configs in your build.gradle files, and with a single Gradle task, you can produce app bundles that are signed and ready for publishing. And also, with app bundles, Play will automatically split your application into architectures, screen density, and language splits by default. you don't need to do any configurations. However, we still want our developers to have full control over their splits. So if for any reason you would like to disable splitting by any dimension, you can do so by using the newly introduced bundle block here. Now, Pierre is going to talk about how to publish your app bundle in the Play console.
Thanks, Ivo. All right, so you have built an app bundle. Now let's look at how you can publish it on Google Play Console. First, you must enroll in App Signing by Google Play. For those who remember, we launched this program at Google I/O last year. When enrolling, you securely transfer your release key to Google Play. Play then uses this release key to sign the generated APKs on your behalf before serving them to users. But note that if you keep uploading APKs on your production track while you test the app bundle in the test track, Play will not resign the uploaded APKs. And we did this so you can feel confident trying the app bundle on a small audience first without affecting your current production users. Once you're enrolled, you can manage your releases just like you did for APKs. Create a new release, drop the app bundles in the same location where you currently drop APKs, and wait for the upload. Once uploaded, you can review your release and roll it out. That's it. And I can't stress this enough, no more multi-APKs to deal with. Play Console has created in the background all the APKs for the supported devices for you. Now, you have uploaded your app bundle and Play has done all the heavy lifting for you. Great. But wouldn't it be nice to be able to have an overview of what Play has generated? Well, we have built a new tool in Play Console called Bundle Explorer. Bundle Explorer lets you navigate your uploaded bundles. Let's have a look. On the first screen, you can see at the top right corner the size savings you gain by publishing a bundle. Here we saved over 1/4 of your app. Of course, this is different by device. So we calculated this using a popular device configuration. You will also find below the list of device configurations and the total size of the APKs served to those devices. You can even click on View Devices and see which devices are in each bucket. You can even search for any supported device by name to download the set of generated APKs that is served to that specific device. This will be super helpful when you get, that bug report on that specific device, and you want to get exactly what the user has gotten, what the APKs were served. So you just search for the name, click Download, and you'll get the set of APKs that Play has served. Of course, we haven't forgotten all of you who use our publishing API. Uploading app bundles is also available using our API today. You will find all the documentation at developers.google.com/Android-publisher. I'll now hand it over to Anthony.
Thanks, Pierre. So we've now learned how to build and publish an Android app bundle. But before we finalize a release, we'd still like to do a round of tests. However, we've seen that the app bundle on its own is not installable. So how do you test it? First, we note that during development, you can install APKs built from the app bundle directly from Android Studio. So you don't need to do anything here. However, for QA teams, we know that they don't always have access to the source code in Android Studio. So let me talk you through the story of 3 developers, Alice, Bob, and Claire, and how they choose to test their app bundle with their QA teams. So let's start with Alice. Alice uses the newly released internal test track from the Play console. The internal track is similar to alpha and beta tracks that you may already be familiar with, but it differs in that there is almost no delay between the upload of the bundle and the update being available on the tester's devices. Really quick turnarounds for your QA testing. Going through the Play console, Alice has the confidence that what the QA team will receive on their device is byte for byte equal with what end users will get when you push your release to production. And let's see how Alice sets this up. Really simple. So Alice creates a list of emails of up to 100 QA testers that are eligible for the internal test track. Her QA testers follow the opt-in link, and then they'll receive the bundles that are uploaded to the to the internal test track. That's it. But we know that not all of you have access to the Play console during your QA cycles. So let's hear from Pierre about Bob's story.
Indeed, Bob doesn't have access to the Play console. He prefers also to test things locally on his machine before uploading anything. But he still wants to test what the users will get. So how does he do that? Well, to generate APKs from the bundle, Play uses a new tool called Bundle Tool. So for Bob to reproduce locally the builds, he can simply download Bundle Tool and write a few simple commands. Bundle Tool has a command called build APKs, which takes an Android app bundle and creates what we call an APK set archive. This APK set contains a collection of APKs ready to be installed on devices. Another command called install APKs takes that APK set archive, extracts the APKs, and install them on that device. Now let's see some real command line work. So here's the command written by Bob, calling build APKs, passing the app bundle, and saying where he wants the APK set to be created. And by passing the flag connected device, Bundle Tool will build APKs just for the device currently connected to his machine. And if Bob wants to generate APKs, say, for someone else in his team, but without having the physical device at hand, he can still provide a file that contains the specifications of the device in a JSON format. And you can see here an extract of such file, which provides the information about the ABIs this device supports, the supported languages, the screen density, and the SDK version. Bundle Tool has also a command to generate such device spec file. So you don't have to find the device spec online, or you don't have to write it yourself. You just run this command, and it will generate this file for you. Also, because Bob wants to install these APKs on a device, the APKs need to be signed with a private key. So he passes the path to the key store. All the APKs contained in the APK set will then be signed and directly installable on Bob's device. And here's the invocation of the install APKs command, which extracts the APKs from the APK set and install them directly on the connected device. Easy. So that was Bob and his local testing. Now, Ibo will tell you Claire's story.
Claire is working for a medium-sized company, and they set up a continuous integration tool to build their application. Every day, the QA team pulls a nightly build of the application, installs in multiple devices, and tests if the application is working correctly. Now, Claire wants to help the QA team, and she uses the bundle tool again to generate the APK set in the CI. She uses a command that's very similar to what Bob used earlier. But this time, she omits the device spec flag, and she generates an APK set which contains APKs for all possible devices. Now the QA team will just grab the APK set from the CI. They're going to connect the device and run the install APKs command. Bundle Tool now will read the device configuration from the attached device, will extract the APKs that matches this configuration from the APK set, and then install them onto the device. This is the same selection that Play does when serving APKs for a given device. One more thing that Bundle Tool can do is to generate a universal APK by passing the universal flag. The universal APK is a single APK that contains the file, all the files that matches all the devices. Because of that, it can be installed in any device. Well, it really doesn't represent what your users will receive when they install your application from Play Store. However, this is a convenient way to pass an APK to a user when you don't know what device they are running. Bundle Tool is also the tool used to build an Android app bundle. And Gradle uses it behind the scenes. We're going to work with the other build chains, tool chains, to integrate Build Tool so that you can build an Android app bundle regardless of any tool chain you may be using. And finally, We want to be transparent about how we generate the APKs we deliver to your users, which is why we're open sourcing Bundle Tool. You can go today to github.com/google/bundle tool to download an executable or build it from the source. Now, Pierre is going to talk about another way to make your applications even smaller.
Thanks, Ibo. With Google Play Dynamic Delivery, we're also introducing a new way to break up your app into separate features and deliver only those that are needed for each user. Suppose you have a recipe app and you want to keep the initial download small. You observe that while all your users like to browse for recipes, only a small fraction choose to actually add a new recipe. And you notice that this functionality takes up significant space in your app. What you can do is break that feature out into its own module and serve it only when needed. We can see how it looks for a user here. Let's open the app. And so when the user wants to add a recipe, he clicks a little plus at the bottom. And you can see that in the background, the module is downloaded and installed. And just after a few seconds, the module is ready to be used. So, which parts of your app should you break out as separate features? If only a small fraction of your users use that feature, that could be a good candidate, especially if that feature takes up significant space in your app. Finally, consider if your users can wait a few seconds before using the feature. Once you've decided which feature to create, this is how it should look like in the app bundle. In addition to the base directory, there are now also separate directories for each of the modules of the app. The format of these directories is exactly the same as the format of the base that I covered earlier. And this is the APKs that Play would generate from it. For each module, we will produce a set of splits consisting of a feature split and config splits for that module. Anthony mentioned earlier that split APKs were only introduced with Android Lollipop. To support pre-L devices, you can mark modules to be fused, and Bundle Tool will generate a single APK with a specified module merged together. Now that we have covered how dynamic features work, let me hand it over to Ibo, who will show you how to create them.
Thanks, Pierre. To create a dynamic module, all you need to do is download Android Studio 3.2 Canary and use the dynamic feature wizard included. Click on the new module in File menu, choose the dynamic module. After typing in your module's name, Android Studio is going to create a new dynamic module for you. You can also do the same thing manually by editing the manifest and build.gradle files. You're going to start with the manifest of your new module. The first step is to declare this module as a new split APK of your app. To do so, you're going to add the split attribute in the manifest tag and give a name, which is VR_viewer in this example. The next step is to add a module tag, which is going to declare a module, and you're going to give a title to the module. This tag is used by Play Store to identify the modules of your application. Next, you declare this module as an on-demand module by adding the on-demand attribute. This means that this module is only going to be delivered to the user's device when the app requests it from the Play Store instead of delivering it at install time. Of course, we now know that on-demand modules are only supported on L+ devices. So if you choose to also provide this module in pre-L devices, you're going to add the fusing tag to instruct Play Store to include this module alongside the base module at install time when delivering to pre-L devices or in the universal APK. Now let's look at the build.gradle files. We're going to start with the dynamic module. The first thing is that we're now using a new plugin called com.android.android-feature. The second thing is we add the base module as a dependency to this module so that we can access the functionality included in the base module. The only change required in the build.gradle file of the base module is to add the dynamic features list and put all the dynamic module names into this list. This is to instruct Gradle to make the resources stored in the base module available to those dynamic modules. Now, Anthony is going to show you how you can use those modules with the new PlayCore library.
Thanks, Ivo. So let's take a look at how you go about requesting on-demand modules to be installed when you want them to be installed. So in order to interact with the Play Store, we are introducing a split install API as part of a new library called the PlayCore library. Now, the PlayCore library is a Java client library that communicates with the Play Store via IPC on the device. And then the Play Store communicates with Play's servers to download these on-demand modules when you request them. Let's take a look at a bit of the code. The API is structured using the same task framework that you're probably familiar with from the Google Play Services APIs and Firebase APIs on Android. Installation of splits is coordinated by a class called the Split Install Manager. You construct a request with all the modules that you wish to download, and then you invoke start install to trigger the Play Store to download the splits required for those requested modules. The API also allows you to listen for updates throughout the download and install process. You can use this to display progress, the download progress and the install progress to your users while they are waiting for the on-demand feature to download. You saw this in the video that Pierre showed when it was downloading the add recipe module. For large modules, you'll need to obtain user confirmation prior to the download via the Split Install API. You'll need to do this whenever the app requests more than 10 megabytes of on-demand modules to be downloaded. However, there is an alternative option for installing these modules, which if they aren't required immediately for immediate use. And we call this the Deferred Installation API. If you use this simple one line to request a deferred install of a module, then the module will be downloaded at a convenient time for the user. So this is generally when the user's not using the device and it's charging and it's on Wi-Fi. And because of this, we allow you to install larger modules via this API without requiring user confirmation, up to 100 megabytes. And so this is a really user-friendly way to download large on-demand modules for your app. You can also use the Split Install API to manage your on-demand modules. So you can see which modules are currently installed, and if your user no longer needs that module, you can request for the module to be uninstalled, freeing up the precious disk space for your users and reducing the footprint of your app on their device. Now, when you go and install an on-demand module, on N+ devices, the app does not need to be restarted. So code is available immediately upon the install completing, and new resources and assets are available once you refresh your context object. However, on Android L and M, installing splits requires the app to restart if you want to install them properly. But to avoid this, we've included a split compat library, which emulates the installation of a split on L and M until the app goes into the background and we can properly install it. And so this split compat library means that your app doesn't need to restart, and all the things inside this, or almost all the things inside this module, are immediately available to your app. You can set this split compat library up in a very similar way to how you might be familiar with setting up the multidex library in your apps. Finally, when you release an update to your app, Play will automatically update both the base module and any on-demand modules that are already installed. So the versions of your modules that are on a device are always in sync. They're always at the same version. And partners tell us that this is something that they really like about this model. All right, so let's wrap this all up. Starting today, all developers can build Android app bundles in Android Studio 3.2 Canary. And they'll be able to publish these on Play to all users. So I encourage all of you to try this out and see how much smaller your app can be just by switching to the Android app bundle. Now, we will be rolling out modularization to developers over the coming months. From today, you can start building modularized apps in the Studio Canary, and you can publish them to the internal and alpha tracks within the Play console. But we'll be opening up publishing in production tracks as a beta over the coming months. And if you're interested, you can register your interest in modularization at the link provided. And with that, thank you everyone for coming. If you have any questions, you can grab us afterwards. I don't think we have time right now. Or you can grab us over the next couple of days in the Sandbox C, just behind the stage. And then thank you. Have a great I/O.
I had a thought yesterday that everything will be okay as long as I make it home. I don't need all the silly things like silver, gold, and diamond rings. All I need is you and me.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits. We'll be making room for those who've registered for the next session. If you've registered for the next session in this room, we ask that you please clear the room and return via the registration line outside. Thank you.
It was another great day at Google I/O 2018, and it isn't over yet. Come back at 8:30 p.m. Pacific Time for our live concert with Justice. They'll be debuting their new song, Stop. Tomorrow, we'll be back here at 8:30 a.m. with more sessions, sandbox demos, and special guest interviews. See you back here in 1.5 hours. We'll leave now with Justice's new music video, Stop.